everyone. My name is Caitlin, and I'm going to be one of your MCs for tonight. I'm a recruitment officer for the college, so you'll probably be seeing me around.
Thanks, Caitlin. I guess I can introduce myself. My name is Carlene Deutscher, and I'm another member of our College of Engineering recruitment team.
So let's jump into what we're going to be talking about today. So the first thing is we're going to be meeting the deans of our college, which are kind of like the principal, kind of like that.
Yeah, but don't get too worried. They're all really nice people, and they're really here to support students and really welcome you into our college. And then after we meet Dr. Cresta and Dr. Sparling, we actually have a chance to meet our APEGS president. And they're actually our title sponsor. Then after that, Caitlin, what are we going to dive into?
Next, we're going to be learning all about the new first year program. Heard that there is no finals and you're confused by how is it possible that a university has no finals. We're going to tell you why. And next,
we're going to have, you're going to meet your professors, because the one really cool thing about our re-engineered program is that you have a dedicated teaching team right here to support you throughout your whole entire first year. So you actually get to meet some of your profs.
Then we're going to do a lab and building tour. And that has been made possible because our profs have been recording a lot of their labs. So you're going to actually get to see what current students are learning in their second, third, and fourth year labs.
And taking it out of the labs and back into extracurricular, you guys are going to get a chance to meet some of your student group leaders. So we have over 21 student groups in the College of Engineering, and you'll get to meet the students who do everything from race cars to artificial arms and robotics to a Mars rover, the tractor team. You get to meet some really cool upper year students who are doing engineering and putting it to the street.
So next, make sure you have your cell phones ready because we are going to be doing a trivia game. So you'll just have to scan a QR code and participate in the game. So normally we'd have a bit of, live interaction if you were in the college, but this is our way to try to get it so you can meet some other students.
And make sure that you participate in that too, because we've got some pretty awesome prizes that we'll be throwing out and sending you in the mail, like an Amazon Echo Dot, some pretty sweet engineering socks. So make sure to stay tuned for that game, because it'll be pretty fun. And then after the game's wrapped up, we're going to meet the Engineering Student Center, which is a team of staff dedicated to your student success.
Then if we are going to learn about the co-op internship program and how you can earn a little bit of money while you're completing your degree. And then finally,
we get to meet some of the alumni and, what can you actually do with an engineering degree once you're out? And, to even circle back, make sure to listen into that co-op program, because you can actually earn PEng hours while you're in your co-op program. And then after that, we're going to flip over into a live Q&A. So throughout the whole entire agenda that we had kind of just previously mentioned, feel free to throw any comments or questions you have into the chat. We've got a team right there to help you out and answer those questions. And once we're done all of our sessions, we're actually going to flip over into a live Q&A chat where you can talk to Dr. Bruce Sparling, our Associate Dean Academic. Maybe you have a question for our academic advisors or our co-op coordinator or our Indigenous Peoples coordinator. So we'll have a full team of our staff here ready to answer questions live as they happen at the later portion of today. So Caitlin, with that, is there anything that I've missed in kind of our agenda run through?
I think that's everything. So we're expecting the Q&A to start at around probably 5:30, 5:45-ish. So make sure that you have all your questions ready. But again, the whole team is going to be in the chat ready to answer questions. So if something comes up and you really want to ask it right away, put it in the chat and we'll be happy to answer it for you. So with that, should we get started?
I think so. Let's go meet our deans. So I am quite excited to introduce to you our deans of the College of Engineering. Joining us along with Caitlin, of course, is our Associate Dean Academics, Dr. Bruce Sparling, and our Dean, Dr. Suzanne Cresta. I'm going to pass it off to Caitlin because she's kind of got some good questions in store for them.
Yeah, for sure. So I was wondering if, Suzanne, if you want to give a welcome to all the students, the parents, the teachers, and the counselors that are joining us today.
That's a fabulous idea, Caitlin. We are just thrilled to have you here with us today. We're really delighted you were able to join us. and look forward to seeing more of you in the future.
So I guess you might as well start by introducing yourself, and could you tell me a bit about your background in engineering?
So I started in engineering in 1986, which will date me a little bit. Actually, I started in 81 and graduated in 86. Spent 26 years at the University of Alberta as a regular academic and came to Saskatchewan in January of 2018 to be the dean of the college. It's been a very exciting time here since then. We've had a lot of changes, a lot of reinvestment and growth, and some wonderful new young academics who are doing terrific things. And we'll be able to talk a little bit later about the redesign of our first year program, which is going extremely well. We're very excited about that, and we can hardly wait to tell you more.
Awesome. Yeah, I'm very excited to tell the students all about the new first year program that I think they're going to really, really enjoy. So then, Bruce, would you mind telling me a bit about yourself?
Okay, sure. I'm a structural engineer by background. Before I came to the university, I worked for Kilbourne Engineering, which is an industrial consulting firm, and they work mostly in the mining and the oil and gas sectors. So that's what I did pre-university, and then my research area since becoming a university prof has been in structural dynamics. So I look at how things vibrate and why, particularly look at wind-induced vibrations of tall structures and things like that.
So I have a question for you, Bruce. There was humming when we went out walking in the blizzard, and we were trying to figure out where it was coming from. Could you answer that question?
I would guess that it might be the power lines that are vibrating in the wind. They call those aeolian vibrations.
Mhm. Pretty impressive.
That's cool. I think that's a cool example of how engineering can really apply into any areas of life, even a blizzard. So I guess that maybe kind of leads into my next question. So Suzanne, what is engineering? That's the question that we're trying to answer today.
Well, that is such a great question. And when I was in high school, we had an engineer come in and talk to us and we kept saying, well, what is engineering? And he kept saying, no, no, it's not that. No, it's not that. And so this has been an ongoing kind of exploration for me as I've worked my way through the profession. And some of the materials that you've developed, Caitlin, really tell a lot of that story because engineers end up doing an awful lot of things. It's about teamwork, it's about leadership, it's about building things, it's about innovating, it's about exploring the edges of what we know and coming up with new design standards and deeper understanding of all sorts of things. It's about serving the public and changing infrastructure. It's about figuring out how to deliver a vaccine that has to be stored at minus 80 degrees C so that we can do that reliably and help us get through this pandemic as fast as we possibly can. So it's difficult to explain because it is so many things. One of the things that I like to use to describe it is people come up with new ideas. So a fashion designer comes up with some astonishing new kind of clothing, like tight skin clothing for ski racing. And the people that build the clothing need to have patterns, they need to have the right needles and machines, they need to have the right kind of sizes and shapes. And so the people between the designer who came up with the new idea and the builders who actually make it with their hands, that process of how are we going to make thousands of these that turn out the right way, all the people in the middle there are the engineers. And the folks that figure out the business plan and the marketing and how we're going to hire people, those tend to have business degrees, but engineers work very, very closely with those folks because an engineer is nothing without a team of people around them. So if you think that you're going to sit in an office and solve math problems, that's actually not even half of the job. getting the job done always involves working with a lot of people and looking out for them and making sure we do the right things for the right reasons. So it's a really, really fascinating and always evolving field. So I have loved every minute of the practice of engineering, and I've done a lot of different things.
And I think, talking about the teamwork kind of aspect to engineering, I think really ties into our culture at USask of us just trying to, collaborate and work together. So I guess that kind of leads into my next question for Bruce. Why should students study engineering at USask, and what's the advantage of coming here?
Okay, well, that's a great question, and I'm a graduate myself of this college, and I'm a lifelong supporter and booster. So I'm really happy. So first of all, what I'd like to say is, I think that you'll hear a lot about our new first year program. I really do believe that that is going to be the best of its kind in Canada. I have no doubt about that. You'll hear all about the terrific instructors we're going to have, the innovative design of the program, all the great experiences you're going to get in that program. And the second thing I would say is that the College of Engineering at the University of Saskatchewan is about the perfect size, I think, because we're big enough to be a research intensive university. We've got world-class labs and equipment, and we're also small enough so that students get access to those labs. They get to have hands-on experience with all of that world-class equipment. And also they get to know their professors, they get to know their fellow students. We really do have a community feel. So it is a really nice size for an engineering college. And I think it sort of, even after you graduate, our alumni are still very closely tied to us. So it's kind of a lifelong family that you belong to. And I think that makes it very special.
I think that's totally right, Bruce. And you're joining our thorough family even by attending this event. We're already welcoming you into this great community that we have. And I think at the end of the day, engineering really fits the whole USask, our new slogan of be what the world needs. The world needs engineers. So so hopefully everyone enjoys themselves today and gets to explore a little bit more of engineering. But with that, Caitlin, I guess we should go and head over and meet with Andrew from APEGS as our title sponsor.
Awesome.
So Suzanne and Bruce will let you sign off. We will see you guys later in the live Q&A session. But if you guys have any questions for either Dr. Cresta or Dr. Sparling, just feel free to throw them in the chat. And now we're going to go and meet with APEGS. So thank you, Suzanne and Bruce. That was a really great introduction into the College of Engineering. So now with me, I am really quite pleased to welcome Andrew Lockwood, who is our president of the APEGS Association. So Andrew, I'm going to pass it right off to you just to introduce yourself, a little bit more maybe about your role with APEGS, and we also get a little bit of a double treat because you're also a USask Engineering alum. So maybe just explain to the students of what kind of engineer you are.
Thanks, Caroline. Folks, my name is Andrew Lockwood, professional engineer, and I am the president of the Association of Professional Engineers and Geoscientists of Saskatchewan, or as you know it, APEGS. I am, of course, the best type of engineer, as people know, the mechanical engineer. We might be a little biased in our family of disciplines, but yeah, I'm a mechanical engineer, and my job is a president, so I lead the APEGS Council. And APEGS, if you're not familiar with it, it's the regulatory body that governs the practice of engineering and geoscience. So professional engineers and professional geoscientists and the licensees of those are all regulated by APEGS on behalf of the people of Saskatchewan. So that's my
Wonderful.
role.
So APEGS is a big, I guess, public service organization in a sense to the province and ensuring that our people and our communities are really safe thanks to the work that you and other engineers do in the province.
Yeah, you could think of it kind of like it's kind of like your driver's license. So SGI regulates the driver's license for drivers to make sure people are safe. APEX acts in the same way in terms of making sure that engineering or geoscience. So if we're talking to potential engineering students, we'll speak in just specifically to professional engineers. Yeah, we make sure that those people that practice professional engineering are trained, are competent, and are ethical in it. And so those are the important things that we want to see in engineers, because if you do those things right, then things are safe. So we build safe buildings, safe roads, safe drinking water, a clean environment, um, cars that don't break down. Those are the types of things you could imagine that an engineer is involved with.
Yeah, I think that's like one of the fascinating things about engineering is that whatever essentially we touch in a day, whether it's through our life's work or play, for the most part, engineers had their stamp on it or signed off or done the design of it. So it's a pretty neat career. I don't think that many different professions and industries can really have that much of a breadth of an impact on society in a really quite positive way. So I
It's
know
true.
we're really grateful today to have APEGS as a sponsor for What is Engineering and supporting and searching for that next future generation of engineers the world needs. And so, is there any kind of opening remarks or welcome greetings that you'd like to give on behalf of APEGS to our high school students?
Well, I'd like to, yeah, certainly welcome everybody on behalf of APEGS, and hopefully, as future engineers in the province, and licensed engineers, because as part of being an engineer, you have to be licensed, which is what APEG's job is. So much like anybody could drive a car, it doesn't mean you're allowed to unless you have a driver's license and you do it properly. So APEGS is the equivalent. So in order to practice engineering in Saskatchewan, you need to be licensed with APEGS. So that's where our role is, and we want to make sure that people, can go home safe every day because of the work that engineers and geoscientists do.
Wonderful. So I guess just as we kind of go into some closing remarks and start getting with the rest of the program that allows our
Yep.
students to explore engineering,
Yeah, I'm
one
excited.
question we're getting from a lot of students is why is a PEng important? And then maybe why can't you actually receive your professional engineering designation just with a 2-year diploma? So
That's
maybe a tougher question to throw your way.
No, good questions though. So why is it a 4-year? I'll start with that one first. So, well, maybe I'll start with the PEng first. So why is it important? One thing is if I mentioned earlier, you're not legally allowed to practice engineering. So there's certain circumstances where you could, but for most people, you have to be a PEng, or you should be a PEng in order to practice engineering in the province. And that's because the public considers that once you're licensed with APEGS, that you're appropriately qualified and you're trained, and you'll do it safely. So you won't just wing it, and bad things could happen. So part of that requirement is you need to have a good knowledge of science, science, math, all the things that come from an engineering degree. And the philosophy is it takes 4 years of education to get appropriately trained. And so that's why, in order to become a full professional engineer, so a PEng, you need to have a 4-year degree from an accredited university, and the University of Saskatchewan is an accredited university for APEGS. So that's why you're able to, as soon as you graduate from the U of S, you can immediately apply to APEGS, which is what most students do. And then you can register to become an engineer in training, and then after about a 4-year window, you can go and get your professional engineer. So it takes about 8 years start to finish, but at the end of it, it's certainly worth it. I'm sure people have already known this, but one of the things is you get to really be at firsthand in the involvement and the development of cool things. There's some amazing things in the world. So the structures and the vehicles and the cutting edge machinery, when we're talking mechanical engineers, and working with huge amounts of earthworks and civil and stuff, like these amazing things where you change society to the better. Every other industry, they help one person at a time, right? A doctor can only help one person at a time. A lawyer can only help one person at a time. An accountant can only help one person at a time. There's only a few things you think, like teachers can help more than one person at a time, somewhat, but they still are usually working with individual students. When an engineer does something, it impacts thousands of people for their lifetime, kind of things. So some really cool things to think about in biomedical. There's all these different things where you can change the world, and those changes actually can happen. And so it's something I'm really passionate about for that, and it's one of the differences between being a professional engineer, and not to soft sell, but because it's licensed, and it can be difficult to get to become a professional engineer, because you've got to go through 4 years of school and then 4 years of practice before you can become a PEng. It also, you get paid pretty good. So Don't forget about that. So there is a reward with all the responsibility for us to keep the public safe and to act in their interest and work hard on their behalf. They do allow us to, it does mean that you get a pretty decent salary at the end of it. So you get to do something you love and have a lot of fun doing it, and you get paid all right for it. So that seems like a pretty good deal for me when I think about going back. And I have no regrets about obviously becoming an engineer. It was one of the best decisions I've ever made.
I think that's what's really interesting, whether people stay in a traditional field of engineering or perhaps go and do something quite unique. They always, first and foremost, they're an engineer. That's how they identify themselves. And I think it just really shows that passion and connection kind of within engineers and that community. And I'm sure you see that tenfold just through APEGS as well.
It is. And my current business, I do less real technical calculations now, and I'm more concerned about risk and safety when it comes to engineering and how we can design things that prevent people from getting injured to begin with. So my role has changed, that I don't do a lot of hand calculations anymore, but still the mindset and the knowledge you get from going through university and getting that thought process and critical thinking and learning how to learn quickly, you can take that and do anything. So I've got good friends that are now business owners. They do not as much engineering anymore, but they absolutely apply that knowledge every day. And like you said, first and foremost, they will identify themselves as an engineer. And because it means something to the public, it means something to us, that they are ethical, they're hardworking. Those are the types of things you see with engineers, especially, and licensed engineers. That's one of the things that we check and we make sure. Part of being licensed is you also maintain your knowledge, so you have to keep your skills up and keep learning all the time.
So before we sign you off and you can go about the rest of your day as a professional engineer, why don't you just give us your one quick, simple answer to why you think high school students should really consider becoming a professional engineer?
If you care about people and you care about changing the world a bit, think about becoming an engineer. And I know as an alumni of the U of S that program, the program and the school do care about that. They really want to do that. And it's that simple. If you think you want to be something bigger and you want to change something a bit bigger, whether it's helping your family, your neighbors, whatever it is, you can do that with engineering. So it's a pretty cool thing.
Yeah, no, I think I always tell students they're not going to go wrong picking a career in engineering.
Perfect. It's been a pleasure, Carlene. Have a good day.
Perfect. We'll see you.
Bye.
All right, well, thank you so much to APEGS. And now I'm going to tell you a little bit about our first year program. So before I get started, I want to acknowledge that the University of Saskatchewan is located on Treaty 6 territory and homeland of the Métis. We pay our respects to the First Nations and Métis ancestors of this place and reaffirm our relationship with one another. So we've been advertising that this is the best program in Canada for engineering, and it's completely new. And I'm going to tell you a little bit why we're different and why we're special. So although there are so many changes I can talk about today, I'm just going to hit on a few key highlights. And all of the other ones that I'm not going to touch on today can be explained by that they're balanced, they're hands-on, and thorough changes for student success. So I'm just going to talk about these 5 things that we've been advertising, and I want to explain them in a little bit more depth. We also have a YouTube video that I'm going to get one of my colleagues to pop in the chat that explains all of the other changes that we've made to our first year program. So to start with modular courses, these are very short, focused, intensive courses that have varying lengths. So you can see here, this is the timetable. When you first start in September, all you're going to be doing is an intro to engineering, and this is going to teach you important things like study skills and time management, what engineering is all about. Another cool thing is you're going to be taking computer science, and this ends in mid-October, so it's going to be a really focused, intense course in computer science, and then you're done. Another cool thing is a natural science series, so instead of picking an elective, you're going to get to experience all of the different sciences that were previously electives. Also in December, the only course you're taking is a major experience leading up into the holidays. At the bottom, you can see that there's fall and winter top-ups, and these are those chances to improve your grades that you may have heard about. Then in the second semester, another really cool module is the design and bridge course. So this is to help transition you into your second year. So it's kind of like a mini capstone course. So if you chose computer engineering, you get to do a little project in computer engineering that relates to what you'd be learning in your upper years. So with these modules, we've been able to introduce this thing called just-in-time learning. You can think of them as like TV crossovers. So the things that you learn in computer science are going to be really important for electrical circuits. And at the same time, the theories and formulas you learn in math, you're going to have to immediately use those in electrical circuits. And this is made possible by our first year teaching team, which in the next section, you're going to get to meet 3 of them. And they're there to make sure that your exams aren't happening on the same day. When I was in my undergrad, there was one day where I had 4 exams in a row, and it was awful. So they're going to make sure that they're a bit more balanced. They're also going to be coordinating the curriculum so that they can have the just-in-time learning, and they're coordinating the assignments to make sure that they're not redundant or you're not missing key pieces of information. You've also heard that we have a balanced schedule and common breaks. So this is what that's going to look like. You can see that everyone starts at 8:30, there's a common lunch break, there's a common afternoon break, and a daily tutorial. So in the previous schedule, you could have maybe had no breaks on Monday, Wednesdays, and Fridays. You maybe had a night class on Tuesdays and Thursdays. And it's just can be hard to schedule your life and to have a healthy balance, and hard to join clubs and find common times to study together. So we're trying to make it more like a high school schedule to make the transition into university easier. The next thing is you've probably heard that we have lots of hands-on learning with our brand new curriculum. So I'm just going to highlight a couple of the cool courses that really focus on hands-on learning. So in December, leading up to the holidays, before you choose your major, you're going to get to experience each of the majors. So you're going to get to do a hands-on experience in computer engineering and engineering physics and geological engineering, so that you can really decide what is the best fit for you and what really fits your personality and your interests. Another cool course is our natural science series. So again, before you'd have to choose between these ones, but now you get to experience all of them with a hands-on lab activity. And this will help you decide if you want to be a chemist or a chemical engineer, so that you're making an informed choice. And with all the other courses, we're trying to make you more employable after your first year. So rather than leaving first year with a foundation in calculus and physics, we're making sure that you are proficient in computer programming. So you're going to get to learn Python and a little bit of MATLAB. You're going to have basic first aid and CPR and WMIS, solid design, CAD, project management to help you land that first summer job. So we have changed the way that we grade students to help them succeed. And with that, we've gotten rid of final exams. And I'm sure you've probably seen this in our advertisements and you're wondering, how did we possibly get rid of final exams? So instead, students are going to be graded throughout their module, and then the final exam period is how we're fitting in those extra experiential learning opportunities. So that's where you're going to have the design courses and the experience in each of the majors. So you've also heard that we are giving students to try and improve their grades. So this is going to be done through competency-based assessment, which is how all of the grades for first year are going to be determined. So to sum this up really quickly, what it means is that we are giving students chances to try again, and we're looking for how well they execute specific skills rather than memorization and guessing on a multiple choice. And to prove that they are experts in the important skills, we're giving them chances to try again, and we're not going to be penalizing them if they stumble earlier in the term. So for example, if you wrote a test and you got a 0, and then you rewrote the test and you got 100, your final grade would be 100 on that learning outcome. You wouldn't be penalized for that 0 in the beginning of the module. And then your chances to try again are going to be during the fall and winter top-ups. So if you remember the schedule, that was kind of the gray bar in the bottom, and those are just your chances to recover if you make a mistake or you didn't understand something from the beginning of the term. So this is how the grading is being split up. So the type A, which is very basic knowledge, we're giving students unlimited opportunities to improve. And what we're looking for is for them to successfully complete these foundational course materials. So we're expecting you to really have a good knowledge of these basic concepts. And the type B, which is the basic skills, you're going to have at least 2 tries to meet our goal of 70%. Sometimes it's going to be 4 or 5 tries to prove that you are competent in the basic skills. And then type C, which is the advanced skills. So that's just normal grading and you're going to get what you get. So we've rebalanced and made all of these changes to our first year program to adapt for student diversity because more than one type of person can become an engineer. So now I'm going to pass it off to some of the teachers from the first year redesign team that are going to tell you a little bit more about first year, and they can also hopefully help answer some of your questions.
Today I had the privilege of introducing you to some of you as a little bit more background into your classes. So why don't we start with Dr. Ma? Why don't you introduce yourself? You can give us your name, your hometown, and maybe what kind of engineer you are.
Thanks, Carlene. Well, I grew up in Mississauga, Ontario, before moving out to Alberta in Edmonton and Calgary, and then to Saskatoon about 6 years ago. I did systems design engineering at the University of Waterloo, a bachelor's degree, then did a master's as well, and then did a PhD in neuroscience at the University of Alberta. And I would call myself a sports engineer now. That's where most of my research is. And that's largely in the areas of mechanical and some electrical engineering activities.
Wonderful. Why don't we go to Dr. Huang next?
Hi everyone, my name is Xiaobo Huang. I was born in a East Coast town, I would call it, in China. And I went to the States for my PhD when I was about 24, 25 years old. And my background was in engineering, but it's called a little bit differently. So it was automation engineering, and then for my master was a control engineering. And before my PhD, I did engineering education, because I think that's a whole new world that worth my effort to devote in.
Wonderful. And last but definitely not least, we have Dr. Fry.
Hi, I'm Joel Fry. I was born and raised in the booming metropolis of Watrous, Saskatchewan, not so very far from the U of S campus. And my background is in electrical engineering, and I have seen most areas of electrical engineering, either through study or practice, everything from thin film devices for medical imaging all the way to giant industrial power systems.
Very interesting. So thank you guys for the 3 of you for joining us here today. And I know it's probably pretty exciting for the students to hear kind of really the diversity of careers really that you can have in engineering, even just from the 3 of you. So imagine taking that and putting it across 8 different disciplines in the college, and you're going to have a really wealth of knowledge from your faculty members and your professors. So you can really, I guess, kind of start to get excited for that. So why don't we go, speaking of classes, jump right into that. What are your classes that you teach, whether it's now or looking forward into our new re-engineered first year program? And maybe what's your favorite part of that class? So who wants to jump into that first?
Joel, you go.
Sure. I've been voluntold. Well, I really do focus on the introduction to engineering and the profession side of things, and I really love the focus on the transferable skills, a lot of the non-technical areas of engineering, communication, leadership, time management, and even study skills. And I really just love being involved in helping the students build a strong, sense of support and knowing how they can achieve success both in engineering and in studying engineering.
Really, yeah, I think something too, probably lots of the first years appreciate just with that transition coming in from high school into university to have someone that's there as their professor kind of helping them through those phases and relearning. So, Xiaobo, maybe you want to answer that one next.
Sure. And now I think I can say I taught statics and dynamics before, because in the past month I just finished teaching the module in statics. What I love the most for these courses is that might be the first set of courses where the students can connect math and other skills like drawing with the physical world. You can see the application of what you learned before, and you can see the value of being an engineer, designing something to solve the problem in the physical world.
Very cool. I think there's a lot of things that they can look forward to as they kind of start to dig into their classes. So, Sean, you're last up on this question.
Okay, and I've been teaching design for many years. Also, along with Xiaobo, I teach statics and dynamics. Been teaching that last few years and will in the coming couple of years. Those are sort of the two main areas, design and sort of introductory mechanics. Also some computer programming like with MATLAB, that sort of thing. What do I like about those teaching those subjects? Well, I really love, much like Xiaobo, the statics and dynamics. It's real engineering. Students are seeing how they're going to understand the world and design things to help improve the world. There's great new understandings that happen there, which students get real excited about. So I love seeing that. Design is one of my major passions, and just seeing how we as engineers design things properly, effectively, to solve problems, which is what engineering is all about. So that introducing that process can be a lot of fun too. It's very creative, and you see sort of entrepreneurial spirit sometimes in those projects as well. So those are some of the main reasons I like those subjects.
Wonderful. So I guess that kind of leads off really nicely into our next question, just talking when you were saying about being creative and being able to be hands-on and problem solvers.
To make the world a better place. As an engineer, you can go on to be a technical engineering expert, you can go on to be a project manager, you can go on to be a business leader. What the skills you learn are so transferable to all aspects of life. Even if you're not 100% certain that engineering is where you want to end up, the skills you learn will be incredibly valuable wherever you go.
Yeah, I totally agree with Joe, as the knowledge and skills that you learn in engineering and the way of thinking you created, developed while you are in engineering, and also the mindset you get from engineering is the thing that valuable to prepare you for anything you want to do in the future, even outside of engineering.
Yep, and I would have to agree with both of my colleagues that I don't have a lot to add. They put it both very well. Engineering is a very versatile degree. It enables you to do much in the future and to go in different directions. You can go into many different disciplines for graduate work if you want. If you have an engineering degree, people value you. So there's a lot of power in having an engineering degree, and people appreciate that. And it's something that you can really leverage for the rest of your life as a way of approaching life and thinking about things and pursuing your career in any number of disciplines. So engineering is a great degree as a foundational degree, and to keep doing engineering for the rest of your life.
Yeah, I totally agree with you guys. Just being able to work with lots of our alumni, I think lots would echo that statement, that really it opens up so many doors. And whether or not you stay in the field of engineering or you go on to even broader things or you combine engineering with other fields, I think the really interesting thing is people first and foremost always identify as an engineer. And I think it's just, that lifelong problem solver that you just are there to help people. So with that, in terms of helping people, you guys had a really unique opportunity to be a part of the team that redesigned our first year program and really re-engineered engineering education in Canada, and it's something we're all really excited for this new class to join in. So the students today will be actually our first class into this new program. Internally, we're all really excited, but maybe we should share with them maybe one thing that you're really the most excited for about this program.
Just one thing?
Well, I know it's probably a whole list, but yes, we're going to have to make you pick down to just one.
We've got lots of things that we're excited about. I'll maybe throw out the first one. The idea of shifting to competency-based assessment, which means basically you have multiple chances to prove that you know what you're doing. If you don't get it the first time, we give you a second or third chance. I think that's going to be something that students will find new. It might be a little unfamiliar at first, but I think people are going to really like that. And it's going to give you a chance, if you stumble, to recover and keep going. So we're quite excited about the competency-based assessment system. It's going to take a little learning for everybody to get the hang of it, but we think it's going to be a big step up. Sure that when you graduate from first year, you know what you're doing, and you're going to have multiple chances to show that you do know what you're doing.
Joel, what's your thing that you're most excited for?
Let me pick. I'm going to go through my top 37. Okay, it's not. I can't pick one. No, I echo what Sean said, and I think what really excites me is this is not a list of classes and things students need to do. Things have been set up and sequenced in a way so that you as a student coming into this program, you will see the application of what you're learning almost immediately. Everything is going to build on itself, and because of the competency-based assessment, it's outcome-based, it should be very clear to you what you need to do to succeed and move forward in your program. There's no tricks. There's very little deception of any kind. If you put the work in to do the things that are clear to you, you need to do to succeed, you can succeed in engineering. And I'm very excited about the way this program will support our students and give them the opportunity, I think, to thrive, not just try to survive.
I would say I hated engineering when I first entered engineering college as a freshman, because I don't see the purpose of learning certain courses. I would say many of those actually, but now this new first year make me excited because it gives the students the more than the application part, also they have the hands-on opportunities and they have the kind of a practical skills they can learn, and once they finish the first year, they can implement them immediately, either probably in intern application or some like a research or experimental project opportunities. So that's something very unique in this first year program.
Can we do another round?
Sure. Do we want to do like a fast fire round of why it's so great and why we're really excited to welcome these students?
Sure. Another element is, this was touched upon, is the deep integration and coordination. In the past, the different courses sort of function independently, but now all your instructors will be working together, and there'll be it'll be like TV shows that have crossovers and stuff. We'll have interaction between the courses. And like Chabot was saying, there'll be a chance to apply things pretty much as soon as you learn them in other contexts. And so that integration is going to hopefully lead to more exciting and deeper learning experiences. So we're excited about that.
Joel or Chabot, do you guys have anything to add of, our fast fire round of extras?
One word, zombies. There will be zombies. I can't tell you what that means, but as a student coming in, look forward at some point in this program for zombies.
And
but
hopefully
not being zombies.
Yes.
You won't be zombies.
Yes, we won't be zombies, but we will be studying zombies.
Very cool. But even on my side of things, that kind of sparks my interest. Chabot, anything to add outside of zombies?
Then the social, or then you can be the social zombies. Can you imagine in college, you can hang out with your buddy, have a coffee together, always during the same time throughout the week, and that's possible in the new first year. And you can even take the same majority of the same class with your best buddy and learn together for the same courses and at the same schedule. So everything is cooperated so well for the courses.
And I think that's really nice too, even if students are maybe coming in from a small town or out of province and they don't know any friends, what a great way to actually have a common break and meet new friends. I know when I started university, there wasn't a single other person in high school that was with me. So I had to go and make all the new friends, but having that common break, it's really a nice startup way to actually meet friends right off the bat, and a nice transition too, right from high school, the big world of university. So I think that's it for our questions for today, but I do want to just maybe quickly open the floor if there's anything else that you guys would like to share with the students today, little maybe a piece of advice or anything that we might have missed just in this little quick introduction into some of their professors.
I suppose when you first arrive, try and hit the ground running. One of the challenges that some first year students have is that they don't really engage until, say, October or something, and by that time you've kind of dug a little bit of a hole. So once you arrive, jump in with both feet, keep up, and we'll try and help you as best we can. Like we're here to help you, so we'll do our best to help you, but make sure you help yourself at the same time, and work hard right from day one, and then you'll be able to be successful all the way along.
Good advice.
And in this program, we will have front-end loaded a lot of the support resources, the things around time management, how you study, how this program works. That's all going to be in the first week or two when you arrive. That might not seem important to you when you see it in those first 2 weeks. It might take you a month to realize how important that was. So don't write that material off, jump right into it, absorb it, and it'll be available to you later when you need it, but take the opportunity early in the term to set yourself up for success.
I'll give some personal experience on this. As you may fail in some tests in your first year, like I failed my first midterm in one class when I was a student. So, but that does not mean you cannot do well in this major. All you need to do is reach out for help and do not keep your questions to yourself. Okay, there are so many, as Dr. Mall and I said, there's so many resources. We're here to help you.
And I think that's one really great thing about engineering at USask is the faculty and staff are really so supportive of students and are really here to help. So just don't be shy, reach out to your professors, reach out to your fellow peers, reach out to a staff member. You're really coming into our thorough family, what we like to call it. So I guess with that, I just want to say thank you guys for joining us today. It was really wonderful to see you virtually, introduce you to some of our future engineering students. And so with that, I will sign off and let you guys enjoy the rest of your day. And hopefully we will see you, I guess, in first year next year.
Hope to see you live in September.
See you, everyone.
Thanks so much.
See ya.
So like, that was pretty cool, right, Caitlin? Like, I wish I had profs that were that interesting in like when I was in first year at university. Like, did you hear the part about zombies?
Yeah,
Like,
I want to know
zombies
how.
in first year?
I'm a little concerned. I hope there's nothing spooky.
Hey, we're prepared. Like, there's a lot of Starbucks on campus. There's a lot of Tim Hortons. You know, you got Louis Loft. Like, if anything can beat zombies, it's definitely caffeine. So I think.
Yeah.
Okay. So why don't we take everyone on a little tour of the engineering building?
So I'm really excited for this part. So what we did is we got a bunch of profs to send us their courses. So you're going to get to see what students are actually getting to learn in their upper year labs. You're going to get to see the wind tunnel and some other really cool places on campus.
Very cool. Let's get to it and let's see the building.
So I'm going to now walk you through the different parts to our diesel engine and show you how this thing works. The engine itself is sitting right here. The engine drives an electric motor which is sitting right here. So this serves as our load. And we use the motor to start up the engine and to start driving the shaft. On this side we've got this big tank here, and this is our air intake. Okay, so now we're going to walk over to this side of the engine. This is where our fuel is. So we've got our fuel tank up here. The fuel comes down through this line like this, around through this tube. This tube actually comes up on the other side here, passes through this filter, and eventually it winds its way into the engine over here. If we walk outside now, so there's a control panel on the outside of this room. This is where our heaters are. So the electrical energy that's created by that generator gets sent out here and it powers these heaters. And depending on how much fuel we're putting through the engine and how much load we're then going to put on the engine corresponding to that, we power a different number of heaters. So the reason why we're using an oscilloscope is because since our engine is running at a very high speed, you have to be able to sample data at a very high rate in order to capture those signals, and an oscilloscope is able to do that. Keep it clean. There are some fumes. We're going to turn the power on to this box. So we've got this switch here, and then we've got this switch here. Alright, so in this video I'm going to walk you through how the wind tunnel works, show you some of the equipment that we use with the wind tunnel. So our fan is located at the top here, so the air passes through a fan there, it moves along the top, and when it gets to the end it comes down, and then it's going to come towards us. So if we walk over here, so when the air comes down like this, it's going to come through this section like this. So over here we have some turbulence reduction screens, so we'll show you a better shot of this in a little bit. We'll walk inside the wind tunnel. So take a look at the turbulence reduction screens over there, and then the cameraman is going to turn around and you can see what the test section looks like from the upstream position. So if we walk back over here, there's a contraction here. So when the air passes through this contraction, it speeds up considerably by a factor of 7. And then it passes through this section, and this is our high-speed test section, which is where we do all our testing. Alright, so now I'm going to walk you through, show you our compressor, show you how it works, show you the different instrumentation. So the compressor is sitting right here. It's pretty big and spaced out compared to how much power it actually produces, and that's more for educational purposes, just so that you can see all the components. We've got the low pressure stage sitting right here. The intercooler is sitting right here. This is this long yellow tube. Okay, on this side here now, we've got, so on this side we have the high pressure stage, so another compression stage where you got another piston inside of here moving up and down. The tall green cylinder here is the aftercooler, which is our second heat exchanger. This big green thing in the middle here is our electric motor. So the flow path for this, there's yellow and blue lines on this thing. The yellow lines represent the flow of air, and the blue lines represent the flow of water.
Welcome to the introductory video for experiment number 3, ion exchange. In this video, we'll be discussing the following. What is ion exchange? Where is ion exchange applied? The objectives of this experiment, the apparatus being used, and the operating procedure. Hello and welcome to the introductory video for experiment number 6, the centrifugal pump. In this video, we'll be discussing the following. How a centrifugal pump works, where is it used, the objectives for this experiment, the pump apparatus, and the active procedures being used.
Hello, my name is Hayden Reitenbach, and I'd like to welcome you to the hydraulics lab within the Department of Civil, Geological, and Environmental Engineering. Behind me here, you'll see one of our many water flumes, or water channels. Within this water channel, we can place any sort of structure, be it a weir, a pier from a bridge, anything you can imagine, and study the flow around that structure, as well as look at hydraulic jumps and many other fascinating features that you might find within the field of hydraulics. Now, while it's nice and quiet in here, I've given you an introduction, but I'm going to switch over to turning the flume on, where things get a little bit noisier and a little bit more exciting. Here, you can see we have a hydraulic jump. This is something that might occur after, say, a weir or some other feature in a river that causes the fast-moving incoming water to jump to a lower speed at a higher depth. This essentially dissipates a lot of the energy in the moving fluid, and it can cause a lot of turbulence that can be dangerous to swimmers. And here to demonstrate the dangers of a submerged hydraulic jump is Elsa, looking fabulous. However, if she falls into the jump, she gets trapped by the recirculating flow and has trouble swimming to safety. All right, that's quite enough of that. She's all right. She's okay.
We go take the sensor off. Okay, now we turn.
To your left, there's a door with an exit sign above it. Okay. And now just point at it. Yeah, just point and like hold the trigger. Laser point. With the door. Yeah, there you go. Okay, so where does that take you? Takes you back here. Okay, so turn. And then there should be like a menu where you want to keep turning. Just turn it around. See black. Okay, so just go to 3 point.
Wow. I wish that I could be on campus and see all the cool things, because that is really only a tiny little bit of the cool things that are on our campus. So once you guys are finally able to come back on campus, it'll be so exciting to give you guys a real tour. So next, you guys are going to get to meet some student groups.
So Caitlin, I know we were kind of talking about zombies before. Why don't you go grab a cup of coffee? I'll grab this next group, and we're going to introduce you guys to some of our student group leaders. So you're going to have people from the Husky Formula Racing team, the Environmental Student Society, as well as our Mars rover team, which is also working on a CUBE satellite for the Canadian Space Agency. So let's hop in and interview those students. And Caitlin, go grab that cup of coffee.
Now I'm really quite excited to introduce to you some of our student group leaders within the College of Engineering. So they're all tuning in here with us today, ready to answer questions hopefully later in the Q&A, but just give you maybe a little bit of insight about being involved in engineering, the great things that you can do, everything from designing Mars rovers to racing cars to building airplanes to being involved with your discipline groups. There's lots of variety. I believe we have over 21 student groups here at the College of Engineering. So let's just do a quick, fast, kind of round question answer. Why don't you give us your name, your discipline that you're in, and the student group and role you're involved with. So Annika, why don't we start with you?
For sure. Hi, everyone. I'm Annika Holmstrom. I'm in chemical engineering. I'm actually on internship this year, and I am the president of Husky Formula Racing.
Hi, I'm Jaden Ladderbrook. I am the vice president of the Chemical Engineering Student Society, and I guess I should have said this first, but I'm in chemical engineering.
Hi, I'm Caitlin McNabb. I'm in 4th year mechanical engineering, and I'm the president of the aero design team.
Wonderful. And you guys will know as we get through this, we have a lot of Caitlin leaders. So if you're Caitlin and considering engineering, it's definitely the right place for you. Now I'm going to pass it off to Olmsted.
Hi everyone, my name is Caitlin Olmsted. I'm a 5th year civil engineering student, and I'm the president for the Engineers Without Borders, University of Saskatchewan chapter.
Caitlin Barron.
Right. Hello, my name is Caitlin Barron. I am in my 5th year of mechanical engineering, and I am the technical director of the U of S air design team.
Hi everyone, my name is Lee. I'm in 4th year in Chem Eng. I'm the president of the Chemical Engineering Student Society.
Hey all, I'm Nathan Hardy, 3rd year mechanical engineering, and I'm the president of the Core Skill Tractor team.
Hi, I'm Nick Duca. I'm in my 4th year of geological engineering. I'm the president of the Geological Engineering Student Society.
Okay, thanks for coming up. And we got Taylor and then Zach now.
Hi, I'm Taylor Zuba. I'm in my hopefully last year of environmental engineering, and I'm the president of the Environmental Engineers Student Society.
All right. Hi, I'm Zachary Reed. I'm the president of the University of Saskatchewan Space Design Team, and I'm in my 4th year of mechanical engineering.
What gets you the most excited about your specific student group or design club? Nathan, how about you?
I'll go first then.
You guys are always hanging out in the Hardy Lab and having lots of fun.
As Carlene says, I love working in the shop. I'm there more than I'm at home probably. I love working with my hands. It's just a great opportunity to get some practical knowledge alongside your engineering degree as well. So.
And Nathan, how, like, when you guys are working on the tractor, what are you kind of gearing the tractor up for competition? Because I know typically you guys go down to the States for that.
Yeah, so every year we design and build a quarter-scale tractor to compete at an international competition in Peoria, Illinois. So there's teams from all over North America and even a team from Israel that come over. So yeah, like there's quite a few tractor events, but then we also submit ahead of time a bunch of written reports, and we also do some presentations down there. So it kind of gives you a nice, well-rounded experience as well. So.
Cool. Anyone else want to jump in, or what gets you up in the morning and excited to be a part of your student group?
Yeah, for me, it's the exact same as what Nate said. I just love working on the race car. I find it so interesting how all the systems have to work together, even though they're designed separately. I don't particularly come from a automotive background, so for me, also just learning as much as I can about the race car, how everything works together, the subtleties of all the designs, I find super interesting.
Being and representing all the disciplines, what gets you kind of excited to be part of your group?
I can answer that. So I think a lot of us can attest to, like, engineering is more fun and easier in a lot of ways if you're doing it with like friends and you're doing things together kind of thing. So in Viros especially, like there's not a whole lot of us. And our kind of group really fosters that community and that like family aspect of engineering, which I personally really like. Like I'm really great friends with everyone that's involved in NBES. And I mean, you don't have to be in environmental engineering either to be kind of involved in NBES. Like Lee, he's in Chem Eng and he comes on all of our discipline tours. So it's just a really great way to have fun and get to know other people that are studying the same stuff as you and make connections that'll last a really long time.
So I know one of the thing that really gets me excited about aero design is the people, and it's really always been the people. I knew I wanted to join a student team when I first got into engineering because I had no practical experience and figured no one would hire me if I didn't get some. And it took me a really long time to start caring about the airplanes themselves, but now I love them and probably want to work in that field. But at the beginning, it was always the people. We have a really good community, and it's just been getting better and better over the years. So, yeah.
So my favorite thing about our group is a lot of us every year get the chance to go to the Canadian Mining Games. It's a big engineering competition with schools and companies from all over Canada. And it's just a great way to socialize, meet people from around the country, and build some good connections with companies.
Yeah, I'll say that.
Go ahead.
One of my favorite things about the team is just all the cool things I've had to learn. Like I know so much more about 3D printing and carbon fiber and all this other cool stuff that I never would have thought I'd ever be able to touch during my school years. So, yeah.
I was just gonna mirror what Caitlin Barron said. We love the people. I'm always so excited meeting new people in like lower years. I've met tons of great friends in upper years. Just joined the chefs, you know. It's honestly been a great experience meeting everyone and networking, and yeah, it's really good.
Jaden, do you think everyone, covered kind of what you were thinking, or is there anything else that you'd like to add?
I mean, I think everyone pretty much covered it. Like Lee said, like our group is really good for building a community, and I know a lot of in past years we've had upper students doing tutorials for some of the I guess lower years, like second year and third year and things like that. And so just building that community and having all of these new connections and it's a really good experience.
So we'll let you guys sign off and enjoy the rest of your day. But thank you again so much for being a part of it. And we'll maybe just give all the students tuning in just a friendly farewell.
Well, Caitlin, I hope you grabbed that cup of coffee and you had a bonus. Very nice. And that you had a chance to just sit back, relax. And then, I think the students gave some really good advice on, just what it's like coming into university. So I know you have an exciting little next step that's coming up in What is Engineering?
Yeah, so next we're going to be playing a game. So make sure that you either have your cell phone with you or another tab in your browser. So a QR code is going to come up, and make sure to scan that, and then it's going to prompt you to put in your name. So make sure if you want to win a prize, make sure to use the name that you registered for on Eventbrite. So I would be Caitlin D, and
Okay,
Carlene.
so Caitlin, then I'm Carlene D?
Yes.
Okay, I'm quite excited. I hope you guys all join. Let's get to the game, Caitlin.
Awesome.
All right, so this is the QR code that you need to get into the game. And make sure that you refresh your browser because there is a little bit of a lag. So once you get into the game, just sit tight and wait just because there is that lag. And if you see that link on the top, if you have a browser, use that too. So I'm just going to give you guys a couple more minutes just to get into the game. I'm just going to make sure everyone is there and ready. And also remember that we have some great prizes. So make sure to participate and open a browser or grab your phone and get ready. I see we have 75 people in the game. Just waiting for a couple more. So remember, you can either use your phone and scan that QR code, or you can type that link into another browser if you're at your desktop. So looks like we have a lot of people. I'm just about to get ready to switch it over. We have 82 people. All right, so I'm going to switch it over now. All right, so if you have your phones ready, I would like to know, what city and town are you guys from? So I'm from Saskatoon and I went to Clavette High School. Oh, cool. So we have Regina, PA, Humboldt, Calgary. I saw in our RSVPs we even had some international students, so I think that is super cool that we have people from all around the world joining us today. So we are so excited to be able to welcome you into the college. We have a really diverse student body at USask. All right, so it looks like almost everyone has answered. So I'm going to go to the next question. What major of engineering are you most interested in? So our most popular major is actually mechanical engineering, which is often our most competitive major. Is no one interested in geological engineering? Oh, there's one. And if you have no clue what major you're interested in, that's fine. That's why we have that bridge course to help you decide what major you are most interested in and try to figure out what your talents are and what your interests are. So it looks like mechanical engineering is our top, followed by computer engineering, chemical engineering, civil, a few electricals. For those people that are considering geological engineering, a cool fact is geological engineering, according to the APEGS salary survey, actually is the highest wages in disciplines. So that's a cool reason to consider geological engineering. So I'm just going to wait a few more minutes for everyone to answer. And I'm going to skip to the next question. So I just want to know, how likely are you to apply to USask if you're thinking of applying to different universities? Are you thinking of programs other than engineering?
So I know when I went into university, I chose the UVS because I'm from Saskatoon, so I wasn't considering other universities, but I wasn't sure what program I wanted to go into until slightly before I applied. So if I can look here, so it looks like most of you guys are planning on coming to USask, which is really great. It looks like some of you guys are applying to different universities, about half it looks like. And not many of you are planning on applying to programs other than engineering. So I think this is just really cool to see what you guys are all interested in and what you are planning on doing. So there's a few more people answering, and again, I apologize for the lag. What you're seeing on your phones probably isn't quite what I'm saying. We'll just wait a few more minutes. So looks like most of you are planning on coming to USask. A real mix of different universities. Some of you are, some of you aren't. And it looks like not many of you are going to apply to programs other than engineering. So that's great to hear that you guys are super pumped about engineering. All right, so next is going to be our trivia game. So I'm just going to wait until the lag is kind of caught up. So for this, remember to enter your name as you registered on Eventbrite. So please your first name with your last initial, just so that we can make sure that if you win, you can win an awesome prize. So we're going to be giving out Echo Dots, some gift cards, socks, so make sure to get ready with our engineering trivia. I'm just going to wait until the lag is caught up. All right, so make sure to be ready on your phones, and the faster you answer the question, the faster, the more points you'll get. All right, so I'm just going to be waiting for everyone to join. We have Liam, Anna. Oh, great, we're getting lots of people. So it looks like we almost have everyone in. We're waiting for a few more people. This is great to see. So I hope you guys are ready. Some of the questions are going to be from the earlier points of the live stream, and some are just going to be some general engineering trivia. So I am going to start the quiz. Is everyone ready? Here we go. When was USask College of Engineering founded? Was it 1907, 1912, 1935, 1954, or 1971? So the correct answer is 1912. So we are a very old college, and it's pretty cool to see that our college was founded not too long after Saskatchewan became a province. So here's the leaderboard, you guys can all see. So it looks like Adam J is winning. Thank you for answering that question super fast. So for the next question, how many student groups does the College of Engineering have? We have 21 student groups. So when you saw that chat, those were just a couple of our student leaders that were thankfully had time to meet with us today. All right, so I'm just going to wait for the lag to catch up to your phones. All right, so looks like Zachary P and Adam J are pretty close, followed by Riley and Dalen. So, for the next question. What engineering student design team traveled to Poland for a competition and brought home the top prize? Wow, most of you guys guessed it right. So yeah, our space design team, they're the ones that build the Mars rover. They got to go to Poland. So hopefully, if you guys are interested in joining that student group, travel will be open again so that you can travel internationally with your design team, which is a super cool thing to not only put on your resume, but also just to get to experience. All right, so it looks like we have Evan S., who has come up in the ranks, and followed by Sophia and Zachary and Adam. So good job. We have a few more questions left. What animal is the College of Engineering's mascot? Is it a moose, a beaver, a husky, or a gopher? And the answer is the College of Engineering's mascot is a beaver, and the University of Saskatchewan's mascot is a husky. So this is a bit of a tricky question, but good job to the 23 people who guessed right. All right, good job. We still have Evan S. as the leader, followed by a few other people. So good job for answering the questions correctly. So moving on to the next question. This is a true or false question. It is true. So good job. Yeah, the next slide, I'm excited to show you this. So first it's going to show you the leaderboard. Good job. We still have Evan in the lead. So for men, 6 out of 10 of the top earners were in engineering, and for women, 7 out of the top disciplines were in engineering, which is a really cool fact. So if you are in engineering because you want to make a decent wage, engineering is a great option for that. All right, so now to the next question. For this one, you can select more than one. So which of these astronauts are also engineers? So actually, all of them are engineers. Chris Hadfield, Buzz Aldrin, and Neil Armstrong were engineers. So again, we still have Evan in the lead. Good job. All right, so what do you think the average salary for engineers is? And this is for Saskatchewan. because APEGS, like we got to hear from APEGS earlier, they're just for Saskatchewan. Wow, good job. A lot of you guys guessed it right. So I think that is super cool to see that that is the average salary, not the low end, not the high end, the average. So that's pretty sweet to see that that's a really great salary. Man, good job, Evan. You are killing it. And then behind we have Natalia and William. For my next question, it's about snowboarding. Do you think the snowboard was invented by an engineer? And true, the snowboard was invented by an engineer, and most of you guys got that right. All right, so we still have Evan in the lead. So I think this is kind of a cool fact, and it just shows you how engineering is part of everything, even in your recreation and your sports. All right, so this is the last question. Who do you think is considered the first engineer? It was actually, I'm not entirely sure how to say his name, but the guy from Egypt. So it was not Leonardo da Vinci like a lot of you guys thought. So he was one of the builders of the step pyramid. So I think that's just a cool fact to show you that engineers have been around forever, and they're building our newest technology and have been around building the pyramids. So if you become an engineer, you're being a part of something that's been around for a long, long time. So now let's look at our winners of the event. So congratulations to Evan. So we have lots of prizes though. So even if you didn't get first place, we may have a prize for you. So good job to everyone who participated. And with that, we're going to go on to the rest of the event. All right, I hope you guys had fun in the game. I know I did. So we will be mailing out the prize shortly. So next on our schedule, you guys get to meet the Engineering Student Center.
So, Caitlin, I'm going to get you to maybe chat with them while I go grab my cup of coffee. But Caitlin's going to be talking with Noreen and Sarah, who are both engineering advisors within the ESC, if you want to use cool lingo. But the ESC really just stands for the Engineering Student Center. And Caitlin also had the chance to talk with Alana. And Caitlin, I guess, what are you guys going to be chatting about?
Yeah, so Alana was thankfully sent us a little video. You can listen for her horse and her dog in the background. So she's going to just be talking about the different supports that we offer for our Indigenous students and what we can do to help you guys out.
Awesome. Well, let's go meet the ESC.
I'm here with the advising team on campus for engineering. So Noreen, do you want to introduce yourself?
Hi, my name is Noreen Prodicala. I'm the Academic Support Services Coordinator for the College of Engineering.
And my name is Sarah Bechter. I'm also an academic advisor in the College of Engineering.
So Noreen, what is the Engineering Student Center and what do you guys do?
We basically help students from the moment they get admitted to the college up to the point of completion of their degree and graduation. So, and in between, of course, there are awards and scholarship, transfer credits, student support. Basically, we're here to help you succeed in your program. And then our unit is also in charge of making sure that our program or our college or meet the accreditation requirement.
So Sarah, how do you guys help students?
For sure. It's a great question, Caitlin. The Engineering Student Center helps students in a variety of ways. So sometimes students, they're not sure which classes to choose. So we can walk them through, for the different, not just first year, but the different majors. This is what you need for chemical engineering, for example, or civil engineering, so that they're taking the right classes. We can help them troubleshoot with scheduling, because sometimes scheduling can be an issue if there's time conflicts with classes that conflict at the same time. We can help students discern and determine which majors are of interest to them. So maybe they really are thinking about that engineering physics major or computer engineering, right? And trying to figure out like which is a better fit for me. So we can point them in the right direction, help troubleshoot with them. We can also really help students figuring out resources. And this can look like anything from academic resources for tutoring or study groups to financial resources, like Noreen mentioned, the scholarships or bursaries, but also health resources, things like just really encouraging overall mental health well-being and physical health well-being. And lastly, one of the things we do is we really help students get connected and become engaged within the college. So that looks like everything from volunteering to job opportunities to student groups, right, and leadership opportunities. Ways that we help students, guide them, and help navigate their time in the college.
Awesome, that's great. You guys do a lot in this college now. You guys are always super busy, just being the rock stars for the students, so we really appreciate that. So Noreen, what is your top tips for students to succeed in engineering, and what are some things that they could maybe do in high school to kind of prep for engineering?
Okay, based on my experience with being an advisor, I would say really that if you get admitted to engineering, that means you have the ability to be successful in engineering. So I would say the best trait or characteristic that I would say students should have, or attitude maybe you could call it, would be in order to be successful in engineering, the most important thing to have would be organizational skills, time management, and also just have that strong study skills and strategies that students need to have in order to succeed in engineering. And also, as a reminder, engineering is kind of a team sport. We've always, maybe you've heard it from family members or friends, like in engineering, it's always good to work with other people, because even in your career, it would be like that. So yeah.
Do you have anything to add, Sarah?
No, I think those are all really great points that Noreen has raised, and just emphasizing how important it is to collaborate with others, and just it really is a team sport. I think that's a great analogy. Yeah.
So my final question for you guys, if we're trying to discover what is engineering, what would you say are characteristics that make a good engineer, or if someone, the best skills that are going to help people out in engineering? If you want to maybe start that one, or Sarah?
Sure. So I think some of the skills or some of the characteristics or traits that students might want to cultivate and continue to kind of grow through high school and then into university, things like curiosity, right? So just being curious about how things work and why they work and when do they work and when do they not work, right? So some of that type of thinking, looking at kind of both the micro and the macro. So engineering is wonderful that way. It could be as very, very detailed as things like within mechanical engineering, right? Like looking at prosthetics or artificial organs and things like that, right? But then it can be also very, very vast when you're looking at things like the cosmos and some of like we have our CubeSat program, right? And so the diversity both in depth of the types of problems and the scope, right? So if able to focus on the micro or the macro, some of the very real issues of today's that are pressing, right? So I think just even that maybe some good things to start with, and Noreen can add too, I guess. So.
being detail oriented would also be one characteristic of a good engineer, because there's this saying, if you're a doctor, you make a mistake, maybe you will harm one person. If you're an engineer, you make a mistake, if you don't pay attention, you might basically harm more than 100 people or so. So the responsibility is there. So yeah, I would say that being persistent would be a very good attitude to have as an engineering student, as an engineer in general. You will be like when you're solving some problems or when you're encountering any challenges, you have to be persistent, right? Do not give up the first time you encounter any challenges. Creativity is also good to have as an engineer, because the same thing. When you're trying to come up with a solution to improve something or to basically find a solution for whatever it is that uh, you want to improve on or to help with, then there's always more than one way to do that.
Well, thank you so much for your time. I think you have some really great insight, and I'm sure the students are going to be very excited to talk to you guys later as they become engineers and they'll get to know you pretty well. So thank you so much for joining me today.
Thank you.
Thank you, Caitlin.
Hi everyone, my name is Alana Ross. I'm the Indigenous Student Initiatives Coordinator at the College of Engineering for the University of Saskatchewan. I'm here to tell you a little bit about our Indigenous initiatives within the College of Engineering. We have a mandate to grow our engineering initiatives by recruiting Indigenous students into engineering, by creating cultural awareness of Indigenous culture and language, but also to develop professional and student opportunities for students to meet with each other, to meet future alumni, and also to find out more about what scholarships are available and internships for Indigenous engineering students. The field of engineering is incredibly exciting, and we are really excited to be able to bring people into clubs and organizations like the American Indian Scientists and Engineering Society. We have a Canadian chapter, and University of Saskatchewan has a post-secondary chapter as well. And so lots of great stuff to do with us, and we hope you choose us. So if you want to learn more about it, please get in touch with our Engineering Student Center, or you can email myself at alana.fitsui@usask.ca. Thank you.
All right, thank you so much to the ESC and talking about all the different supports we offer for students. And now we're going to show you some more supports we have, like scholarships and bursaries. So I'm just going to share a presentation so that you guys can learn a little bit more about scholarships. So at the U of S and the College of Engineering, we have lots of great scholarships available for you guys.
So last year, we actually had over $2 million available to engineering students, which actually largely is supported by our alumni and industry. So when you come into the college, there's a whole backing of people here that are really ready to see you succeed. And I guess, Caitlin, when we go through these, a good point to point out is that we have scholarships, which are available to anyone, but then we also have bursaries, which are based on financial need. So I always like to refer and talk about scholarships and connect it in with our Wayne Gretzky quote of "You miss 100% of the shots you don't take." So go ahead and just apply for scholarships, because you just never know.
And another thing with a lot of scholarships is sometimes they have very specific requirements they're looking for, and so some of them don't even get taken. So definitely go through and spend the time looking at the scholarships and applying for anything you're eligible for. So these are the scholarships that you actually don't have to apply for. So these are called guaranteed entrance scholarships, and these are determined when you submit your 5-subject average. Those are, you can look on our website to figure out how those are calculated, but it's just mostly kind of your 5 best classes, including math and English. So what I always point out to high school students is if you are right now sitting at, let's say, a 92.8 average, make sure to try to bump that up to a 93, because you can get an extra $1,000. So it's kind of good to keep these percentages in mind when you're trying to figure out your average so you can get some really awesome scholarships.
And now's a great time to do it. You know, you're still early enough in your school year.
We also have the best and brightest. So if you're a really high achieving student who's getting really great grades, make sure to apply for these because you can get up to $40,000. And these aren't, you know, crazy far away, the best people who get them. Like some of my friends have gotten these and they had their entire degree paid for. So make sure to apply. But to be eligible for these, you need to apply for admissions by December 1st. And you need to submit your documents by December 15th. So do this as soon as possible if you want to snatch up some of these scholarships. Then we also offer competitive entrance awards. So these are based off of things like leadership or maybe financial need, or sometimes just very specific criteria like someone with a family in mining, for example. So make sure to go on our website and check these out. So here is our website where you can find out about all the scholarships. So if you go to admissions, click on money, and then go down to scholarships. So this gives you all the eligibility for the guaranteed entrance. These are all the best and brightest.
Summary too, hey, of like everything that we already kind of went through. So if you need to find it in text, it's right there for you.
Yeah, it's super easy. It's great to find. So what I really want to highlight here is the competitive entrance. So click on this button. And this is where you can search for awards. So, for example, if you want to look at just engineering, go find awards. And this gives you a list of all of the scholarships that are for engineering students.
And Caitlin, those are just the entrance awards. So once you're actually an engineering student as well, once again, you have that $2 million of available scholarships and bursaries to apply for. So it's, you know, it's not just a one stop. Once you're into first year, you have the rest of your entire degree to apply for these some really, really quite amazing scholarships.
Yeah, it's really awesome. And then it's super easy, you know, if you click on this one, like the APEGS scholarship, which is actually our sponsor for today, these are the different scholarships that they offer. So you can look through and find the eligibility, and then you can also apply online. So super easy. Make sure to check out this website because there's lots of great awards.
Our next segment is actually going to be talking with Kristen and Tracy from our co-op program about, guess what? The topic is still money. So it's how do you earn some cash in your undergrad, but also get some really, really great industry experience that you're able to apply your engineering education hands-on right while you're still in school, plus a little bit of bonuses, engineering students. There is a potential opportunity for you to actually earn some PEng hours. So Caitlin, why don't you introduce this segment because it's a little bit more unique than our other ones that we've had today.
Yeah, so me and Carlene had the opportunity to go onto campus and film a little video with Kristen and Tracy. So I'm super excited to show you guys this video. And if you want to watch it again or, you know, show someone else the video, it'll be available on our YouTube channel and on our website later. So make sure to check it out, and here's the video.
Do you want to graduate with real work experience and earn a competitive salary? Think about the co-op program. Hi, my name is Kristen Cutting and I'm the co-op and career coordinator for the College of Engineering.
Hi, I'm Tracy MacArthur and I'm the co-op coordinator for our program. I'm also a professional engineer with a background in civil engineering.
By joining the co-op program, you're going to gain hands-on work experience, build your resume, and be able to network with professionals. It's a great way to start your career. You'll get a great advantage applying for jobs after you graduate and get a good head start on who you might want to work for and find out what industry works best for you. You'll have access to a supported learning environment with program staff here to help you find your job. You'll have access to an on-site mentor who's probably going to be a professional engineer and an industry mentor to help guide you through the transition from your school to the professional workplace.
With our program, you can go out for 4 months, 8 months, 12 months or 16 months. It's very flexible for you and the employers. Our students go on placements all across Canada. You can go on a work placement as early as after your second year. In this program, you can get up to 20 months of experience and you can do it with different employers. Our program is designed to work with your academic schedule. With that, you can go out in May, September, or January.
What's great about our program is that you don't have to decide right away if you want to participate. You'll complete your first year of engineering and then you can decide if you want to go into the co-op program. To be eligible for it, you need to have an average of 65% or more in your 2 academic semesters before you apply, and you need to be able to maintain that average after as well.
In 2020, amidst the pandemic, there were 125 students placed. 139 students were placed in 2019. The average salary for our students is $26 an hour. 66% of placements are in Saskatchewan. However, placements can be all over Canada.
Students in all of our 8 programs are eligible to participate in the co-op program. Here's a list of some of the places where our students are working right now in a wide variety of different types of industries. We encourage you to seek placements that are interesting to you and find out what kind of industry is the best fit for you. If you're willing to relocate, there are tons of opportunities out there for you.
To apply to our program, in the second term of your first year, you can attend an information session to learn about the program and how to apply.
Here are the top 3 reasons you should join the co-op program. You can gain some great hands-on work experience
so that when you graduate, you're more employable. 2, earn money doing it.
And be able to balance your academic schedule with getting some professional experience. In addition, did you know that your hours actually can count towards your professional designation? It's a great way to start your career.
Our program is designed for you.
Next up, we are going to explore the life and professions of some of our USask Engineering alumni. So, as you enter your first year of engineering, you actually automatically become a part of our thorough family. You're joining a network of 12,000 USask Engineering alumni who are spread across the whole entire globe and are really here to help and support you succeed as an engineering student, but also as a professional engineer. So, we often get asked, well, what are your USask alumni? Who are they as people? Well, it's easy. They're the creators, the innovators, the entrepreneurs, the difference makers, the adventurers, the designers, the protectors, and the leaders, and so much more. It's a really broad and diverse group of professionals. So let's go and explore and meet some of our engineering alumni. I'd like to introduce you to Shanti Bergen, who we've dubbed as our protector engineer. Shanti has earned her undergraduate and her master's in mechanical engineering here from USask. And throughout her research, she's actually studied different hydraulic fluids and their flammability, which was all led on helping to keep potash miners safer while working underground. Next up is Kara Carter, who is our explorer. She is a graduate of our engineering physics program. So when she was traveling to Europe to learn more about her engineering physics and her education, she actually stumbled upon a casting agent for HBO's hit show Game of Thrones and became an extra, and she's already signed on for the prequel. So it's pretty exciting that she's been able to travel the world with her engineering degree, furthering her education, and, got to land on probably one of the world's most popular shows. Jillian Pinder, a mechanical alum of ours, is living every athlete's dream. She is now living and working in Portland, Oregon, hired actually by another USask engineer at Adidas to design different athletic shoes and just a whole line of athletic wear within Adidas. Next up is Thomas Laverne. Now, Thomas is our difference maker. He's an environmental engineer who's really committed to northern communities and helping remediated mine sites transform back into their natural state and used as a resource for trapping, hunting, and fishing. Lisa Franks, it's pretty cool to say that we have a USask Olympian as a member of our thorough family.
So Lisa is a member of the Paralympic team for wheelchair basketball and as well as the sprint events. Off the track and off the court, she's a mechanical engineer working with Stantec. Now, Chirac, you guys might have heard his story because he is, when he was actually a student, worked his way to getting an internship with Tesla, actually working down the office from Elon Musk. So he landed that job through his work with the Husky Formula Racing team, and he now lives in the States, working within the automotive industry. Next is Harrison Bull, and he's dubbed as our defender. And it was really a love of nature that sparked Harrison's interest in engineering. He has a chemical engineering degree and is now pursuing his master's in civil, focusing on water treatment and environmental radiation. So here's someone, really making it a safer place for our communities. Tara, I think, has a really unique path into how she found engineering. She was trying to decide between a fine arts degree and engineering, and she actually ended up coming into engineering because she thought it was a really great opportunity to be creative, but also satisfy that need for curiosity and problem solving. If anyone's familiar with downtown Saskatoon, Tara actually was the project manager and led the build of the major big skyscrapers new to the River Landing project. So it's pretty unique that a USask engineer has had such an amazing impact on our city. So you've met some of our alumni, but maybe you're still asking yourself, what do different engineers actually do? So let's just do a quick little high-speed synopsis, and then you can answer and maybe get a few more questions answered during the live Q&A. So we have our mechanical engineers, and how we like to break down the work of mechanical engineers is that they focus on how things work, and they really see everything as parts in motion. So that can be everything from, designing roller coasters to different engines to something as small as a little part on a different type of machinery. Chemical engineers are truly chemists in action. They solve problems and create useful products to help people. You're going to find the work of chemical engineers in everything from cosmetics to pharmaceuticals to pulp and paper to oil and gas, really a wide diversity of fields within Chem-Eng. Electrical engineers power our world through power systems, communications, and electronic products. It can be something as large as a telephone pole and seeing a power system down the highway if you're traveling, to something as small as a little electronic device within our computers. I think one really unique story of how electrical engineers at USask have really transformed the world is one of our alumni actually developed technology that has completely transformed breast cancer detection. Next up is our computer engineers. We all know that we're living in a world that's more and more focused on technology. So it's really the job of computer engineers to create and improve technologies and hardware that really shape our modern world. I think engineering physics is a really cool discipline because it bridges pure and applied science to help our world's rapidly changing and highly technical environment. We have engineering physics alumni who have gone to work for SpaceX, the Canadian Space Agency, to SED Systems designing satellite and communication systems. So it's a very cool discipline. We also have our environmental engineers, and as a job as an enviro, your job is to protect and improve people's health and our environment, which really includes everything from our air, water, and land. As a geological engineer, the saying is, if you can't grow it, you need to mine it. And their job is to connect nature and engineering to really fuel our world using natural materials and fluids found within our earth. Last but not least is our civil engineers. And, if you've traveled on a road or you've had clean drinking water, you can more than likely thank a civil engineer. They really build our physical world, everything from roads to airports to water systems and more. That is the job of a civil engineer. So with that, that's a really quick summary of our different disciplines within USask Engineering. And now I'm going to pass it off over.
All right. So we are ready to start the live Q&As.
So if you have any questions, make sure to pop them in the YouTube chat. And I'm going to switch over to our presenter.
Hello, everyone. I am so delighted that you've been able to join us today for What is Engineering. So now we're flipping over into the live Q&A session. And I just want to do a little bit of a roundtable just to quickly introduce everyone. So as I go around our little virtual group table here, I'm just going to get people to quickly turn on their video, give us a quick hello, and then turn their video off. So I am going to start first with our Dean, Dr. Suzanne Cresta. Suzanne, if you just want to flip on your video, give us a quick hello.
Hello, everyone. Welcome. We're delighted to have you here with us today.
Wonderful. Now we'll take it back to Bruce. And if you could introduce yourself. Bruce is our Associate Dean Academic and a civil engineer. I should have also mentioned Suzanne is a chemical engineer herself. Oh, I think we got you on mute, Bruce.
Okay.
There you go.
Okay. Well, it's great to have everybody with us. I was watching the program and I hope you have been enjoying it.
Wonderful. Next up is someone that's hopping in and giving a little bit of a student perspective. Annika Holstrom is our president of our HFR team. Annika, if you just want to flip on your camera so everyone can see your smiling face.
Hi, everyone.
Wonderful. Thank you so much for joining us. And next up, we'll go to Sarah Bechter, one of our engineering academic advisors.
Sure. So welcome everyone here today. It's great to have you all joining us, and we look forward to welcoming you once you become students in our college. So just enjoy the rest of the event tonight.
Well, thanks, Sarah. And we'll go to our other academic advisor and student support is Noreen Predicala. Oh, I think we've got you on mute, Noreen. While Noreen's getting her audio figured out, why don't we hop over to Alana Bitsui and she can introduce herself.
Hi everyone, Tensei. My name's Alana Bitsui and I'm happy to answer any questions you have about Indigenous initiatives in the college.
Wonderful. And Alana, thank you for joining us all the way from Duck Lake. We've got a good range covering the province on our team as well. Next up is Kristen Cutting, and she is our programs coordinator for our co-op and internships.
Hi, everyone. Thanks so much for joining us. Looking forward to hearing your questions.
And you guys got to meet them a little bit earlier in our program, but we also have two of your first-year professors joining us. So Dr. Sean Ma, if you'd like to turn on your camera and give the students a quick hello.
Hello, everyone. Looking forward to seeing you soon.
Hopefully soon. And then next up, we've also mentioned have another engineering prof, Dr. Xiaobo Huang, if you want to turn on your camera and welcome everyone.
Hello, everyone. I look forward to seeing you in person in the future.
Wonderful. And Noreen, were you able to figure out your camera and audio?
Yes. Can you hear me now?
We can hear you loud and clear.
Welcome, everyone. I hope you're all enjoying this event, and we're here to answer your questions, and we really look forward to having you in our college, hopefully soon.
Wonderful. So now we're going to flip over. We've got a little bit of questions that we've jotted down throughout the program. So it was really great to see those questions coming in through the chat. And there's one question actually that just popped in here from Petro. And I think I'm going to ask Dr. Ma to expand on this a little bit more. just ask if you can elaborate more on the no finals in first year. Just how does that actually work within the re-engineered program? And we know that's something students are excited to hear about.
Yes, I imagine so. Well, we don't want to oversell that point too much. There won't be final exams at the end of the term for two reasons. One, courses won't always be running the full length of the term. So if there is a test at the end of a module, it may not fall at the end of the term. The other reason is that we're doing testing by module, so there is no real final exams to be had anymore with the new first year, the re-engineered first year. Instead, it'll be more like a series of midterms. And it's not that things are going to be easier. It's not like we're just getting rid of finals and everything's so much easier that way. We're spreading out the assessment and evaluation over other assessments. And so there'll be essentially a series of midterms, if you will. We'll be calling them module tests, as well as assignments and that sort of thing. But the good news is that going into Christmas, into the Christmas holidays, you won't have exams, and what you will have are one-day immersions into the different engineering disciplines, and that's more participatory. There won't be any big deliverables there, so it'll be a nice relaxing way to finish the fall term as you go into the Christmas holidays. And in the at the end of the winter term, similarly, there'll be a design course going and another course going. So there could be a test or two to finish up, but it won't be a series of exams like there are right now.
Great. Thank you so much, Sean, for answering that. And I think that immersive experience is something that students are really, really going to be excited and looking forward to. So I'm going to go up to another kind of maybe a dual question here, one that we had earlier in our program, and then one that just popped up again regarding transfer credits over to the U of R, and then what is the difference between the systems engineering and then the programs that we offer here at the U of S. So Dr. Sparling is our Associate Dean Academic, and I think he's probably the one that can give you a really great answer of, you know, what is the difference between our programs here at USask and maybe how transfer credits work. And I know Sarah Bechter might want to hop on for the transfer credits question as well.
Okay, well, I think I will let Sarah take the transfer credit question. That's her specialty, one of her specialties. But in terms of what's the difference, at the USask, we tend to focus on the disciplines that are more aligned to what perhaps the industry would be used to seeing. So if you could go anywhere in the world and they'll know what a civil engineering is and what a mechanical engineering is and so on. And so we tend to go into those disciplines, and we focus more on the technical aspects, and so you get a very, very solid foundation in the technical aspects, and then we provide additional training supplemental to that you have, and you've probably heard about some of those options. So whereas the U of R, they have sort of more non-traditional disciplines that they call systems engineering, and they focus on maybe other aspects that are maybe a little broader and less technical than we do.
I'll just jump in if Dr. Sparling is done with his response there. So the question about transfer credits is a common one and one that we get often. And so with transfer credits, just so that students have a good global understanding of how they work, essentially, if a student would be switching from our institution elsewhere or coming in, it's always the receiving institution that makes the final decision in terms of what transfer credits may or may not be applied within a program, right? So the specific question that Michael had asked us earlier was just wondering about, you know, can our first-year engineering courses count to external institutions such as Waterloo or Toronto? And those are just examples, but in each individual case, it would be those institutions, whichever ones you are looking elsewhere, that would actually be evaluating it and determining if it would fit within their program, and vice versa, that if you would be transferring here from another institution, we definitely welcome transfer students, and we really try to work with them to bridge any credit courses that they might have done previous coursework. But again, we would just have to see how those specific transfer credits could or could not fit into your current program here at the university. So that's just a little bit of, again, an overview of transfer credits. And again, we would work with students individually to assess that and to see what that fit would look like. So.
Wonderful. Thank you, Sarah. You always do such a great job of answering students' questions, and you're always very nice and clear and concise. Annika, I'm going to get you to turn on your camera because we've got a few kind of questions here that are more kind of the student group related, and I think you're the perfect person to kind of speak to it because one, it deals directly with your team that you're the president of. We have Cindy R asking, how hard is it to get on the formula team?
For our team specifically, there's pretty much no requirements for joining. It's open to all undergraduate students at the U of S. Doesn't matter discipline, doesn't matter year, doesn't matter any previous experience. I actually joined the team in my first year with very little automotive experience, and I'm also in chemical engineering, which is a bit of a different fit for a lot of the other folks on the team. But yeah, it just goes to show that we're very, very open to everyone, and we love to have a diverse group on the team. I think you're muted there, Carlene.
I was muted. See, it can even happen to the host. I think it's really great, you know, even when we are back within the college and seeing the Husky Formula Racing team, you know, you're working in the same space as the tractor team, as well as the USST and the aero team. So even within the teams, I think it's pretty neat to see the collaboration that happens and the cross disciplines and stuff like that, and just how friendly and welcoming, and there's a spot for everyone on any team at kind of whatever capacity you'd like to take it on.
Oh yeah, for sure.
Thank you so much, Annika. You can turn your camera off now. And there was a good question here. Maybe this is a question for either Bruce, Sean, or Xiaobo to take the answer at. And asking, will there be short and focused modular classes, no final exams, common breaks, and top-ups in second or the upper year classes? So essentially, how is re-engineered going to be rolled up into our senior classes?
Well, I guess I could take a shot at that, and then maybe Sean can add to it. So our re-engineered first year, this is really, we're launching many of these things, and of course we'll be looking at what really works well and what we can import into other parts of our program. So we will be doing that, but it's kind of an evolution from there. And so hopefully we'll take the best ideas, the ones that work really, really well, and you will be seeing those hopefully in your upper years. But that's going to take a little bit of time for it to get there.
Wonderful. Sean or Xiaobo, would you guys like to add anything into that, or maybe even how this, you know, lots of the students within the current first year class that you guys are teaching in the GE 124 are just loving how the format is of re-engineered. So I don't know if maybe you want to speak to that and just maybe the student experience of how this is actually going in our test sample class.
Right. Well, sure, we can address that. We're using the competency-based assessment scheme, which is significantly different from sort of regular assessment practices. We're using that in the statics course this fall. I think the students are quite liking it. It's giving students a second chance if they stumble, and then they capitalize on that and you maybe do better on a second try, and that allows them to keep going. So there's that advantage. We're also seeing that some students appreciate the focus on learning outcomes, so they know what they're supposed to be working hard on, and they have that clarity. So that has been another sort of popular angle on it, I think. We do have, of course, remote teaching right now. It's a little different than in person. So, we look forward to hopefully seeing you all in the flesh next fall. And we'll be applying some of these principles across all of the courses with you next fall.
Wonderful. Thank you so much, Sean, for answering that. We might kind of just jump around a little bit here in our questions. And Kristen, I'll get you to turn on your camera. As you can see, we have a few questions coming in co-ops asking, everything from, are there a lot of co-op options in chemical engineering? How many people typically apply into the co-op? How many are admitted? So I don't know if you'd like to tackle maybe just those two questions for now, and I can circle back with some more for you.
Sure, that sounds great. So in terms of applications to the program, I think this year we had about 265 students apply. One of the nice things about the program is that we don't have a set number of seats. And so as long as students are able to meet the criteria of the program, they're able to get in. So it's always a good feeling when you don't have to turn people away. In terms of sort of the chemical engineering opportunities, there are many, and within different types of industries in different locations. And so it kind of comes down to each individual's preference in terms of where they want to work. And I always advise to students, the wider that you cast your net, when it comes to doing your job search, the more likely you're going to be to succeed. And so really coming into the program with an open mind in terms of where you might want to work and thinking about this as an opportunity to learn about an industry, to learn what works for you in your professional life is sort of what we advocate for students in the program.
Wonderful. Thank you so much, Kristen. I'm just going to look through kind of our questions here. We have quite a few coming in about asking about the various disciplines, and Dr. Cressa just had to step out to another meeting, but when she's back, she has a really, really great answer on how to tackle this question. So I'm going to wait for that. And if one of our alumni is still tuning in, Mike McGuire, I'm going to ask you, actually, I'm going to call you to action and to answer in the chat about engineering physics. And Mike is one of our dedicated alumni who works with our Engineering Advancement Trust, our USST student design group, and is a big advocate of EP and really the whole diversity that engineering physics can have. So I'm just going to quickly go back and revisit our chat here. And just to make sure, it's really wonderful to see that we've got so many different questions coming in. So I know there was a question that we had that was in regards to all of the majors that we have. So as we went over in the presentations, there are 8 majors to pick from, but how does that process actually work in terms of, how many choices do the students get to pick? How is that decided? Do they get to pick? Does the university pick those for them out of their top selections? How does that work? So I'm going to pass this question off to either Noreen or Sarah to answer from the Engineering Student Center, because that is your go-to source once you're in school for selecting your majors.
Okay, so maybe I'll take that question. For program selection, students are asked to submit their top 3 choice, so their first, second, and third choice. And after that, we decide like where they will be assigned based on their average. So we will consider their first choice first, and then we will rank them on that program. If they meet the cutoff average for that program, then they will get their first choice. If in case their average is not enough for their first choice, then they will be considered for their first choice. So that's how we do our ranking for program selection. It will be based on their first year courses average. So that's how we do the selection.
Perfect. Thanks, Noreen. And if that wasn't clear, if anyone has any questions, just keep throwing them down in the chat and we'll be monitoring that. Bruce, I'm going to get you to throw on your camera for a second. because we had a really great question coming in actually about civil engineering. So we're in for a little bit of a treat because Bruce himself is a civil engineer and might be able to answer this question. So the question reads, if you study civil engineering as a first degree, can you do a master's degree in architecture with it? And is there any advantage of going straight to studying architecture as a first degree in comparison to civil engineering, and kind of maybe what diversity or benefits would a civil engineering degree have?
Okay, well, that's a really great question, and there are a number of people around who have gone that route and taken a civil engineering degree. And within civil engineering, one of the subspecialties is structural engineering, which is what I am. So you design buildings, the strength of the buildings, the sort of the physical elements of the building to make sure that they're strong enough and they perform the function that the building is designed for. And then that complements architecture very well, which is more the form and the function of the building. So you sort of see it from all different angles, and it really makes you a well-rounded professional. You do need a master's anyway to practice architecture. And so civil engineering is a really great first degree that can launch you into that.
Wonderful. Thanks so much, Bruce, for answering that. And I think just to build on that, is that you're seeing this question of, is it civil engineering? Do I want to go into architecture? We do have a lot of alumni that have gone on to pursue another degree after their engineering degree. And Sean, maybe I'll get you to turn on your camera, because I know you've mentioned this and these connections too. Between engineering, and I think that's a really, really unique thing about engineers, is that first and foremost, they always identify as an engineer, whether they go on into medical, the field, or like the architectural field. There's always that core commitment and that real passion for engineering and design and problem solving that I don't think you can get with any other degree. So I'm going to get you maybe to chime in and add a little bit of your special touch onto that one.
Okay. Thanks, Carlene, and I would agree with you completely. So my background is I did a bachelor's and a master's degree in systems design engineering at Waterloo, and then I did a PhD in neuroscience. Now, I didn't know a whole lot about neuroscience before I did a PhD in neuroscience. I certainly picked up some basics in my master's, working partly in kinesiology, but being an engineer, I felt that I was capable of making that jump. Engineering students are very valuable to people in other fields. So if you're wanting to do graduate work later, they'll appreciate the fact that you're an engineer. I still thought of myself as an engineer going into neuroscience, and being an engineer, you come with a certain outlook and a certain way of looking at the world. I was doing my PhD, and one of my friends was a medical doctor. So he was a medical doctor doing a research PhD. And his way of looking at neuroscience was to memorize everything. And from my training as an engineer, it was to try and understand what was going on. And so, I mean, he was very capable at remembering all sorts of things, probably better than I was. But when it came time to understanding how things worked, and if he was asked a question about how something might function in terms of the neuroscience, he had trouble with that. But coming from an engineering background, that's where I was able to excel. And engineers are versatile. So you learn a way of looking at the world, a way of problem solving that can help you for the rest of your life in a variety of different facets of life. So I am very glad I went into engineering, and it has served me well to this day, and it still shows me the world in a way that is really helpful for understanding it. So I would highly recommend engineering as a way to go, because it's so versatile.
Thank you, Sean. You always do such a great job of answering that question, and I think it's the coolest thing about engineering is that you can really take it and make it your own. We're going to circle back into the co-op questions just briefly. Kristen, we had a question asking if students can apply for co-ops in the States and how that works. And I know like during the alumni feature, we got to meet Niles, who actually did his internship with Tesla, and that was something he kind of self-found, but maybe you can expand a little bit more onto that.
Sure. Yeah. Thanks, Carlene. So generally speaking, the majority of our students would be working within Canada. It's not to say that they can't go abroad, and we consider the US abroad. The one thing I would say, though, is that right now, just because of the situation with COVID, there are some restrictions in place. So if a student were to ask me today, can I go to the US on a placement starting in January? Unfortunately, we couldn't send anybody. But I think when it comes to sort of the abroad opportunities, it's something that you can certainly pursue, and you would work with the program staff as well as with some of the staff in our International Student and Study Abroad Center, just to make sure that you had the support required to get the appropriate documentation to be able to work either in the US or into other countries. But again, unfortunately, you know, with COVID, it has placed some restrictions on what students are able to do right now.
Wonderful. Thanks, Kristen. I think you, along with all of our other students, and I'm just going to go out on a limb and say our whole entire world is just really hoping that COVID wraps up its business, and hopefully we can resume back to all the fun and exciting things we got to do pre-COVID. So I'm going to ask our dean, Dr. Suzanne Cresta, to turn on her camera. And we had a lot of questions coming in about, you know, I really want to do space studying, or I want to go into EP. What kind of jobs can I get? I understand it's a mix of that, like pure science in the engineering world. I want to study civil engineering. And you have the perfect way of describing and explaining what the different disciplines do and kind of the variety of careers. So I'm going to pass, I guess, a few questions rolled into one off to you.
Thanks a lot, Carlene. I love the way that people put those questions today. There were some really thoughtful, detailed pieces of understanding that really show that people are thinking hard about what they want to do. So kudos to all of you. What I'm going to do is provide a pretty simple explanation of the kinds of things the different disciplines look after. So things that don't move, bridges, buildings, overpasses, that tends to be civil engineers. Things with moving parts, mechanical engineers, roller coasters like you saw in the video, robots, plants that build things, manufacturing, bottling lines, that's mechanical engineers. If you plug it into a wall or charge it, then an electrical engineer had something to do with that. Chemical engineering is my discipline, and that's things that you mix, react, and separate, where you control the temperature and pressure. So we make money through chemical reactions mostly, but a lot of liquid and solid processing. So a continuous thing. Biomedical engineering is a multidisciplinary activity, and as Sean mentioned, it tends to be a graduate program. So you build yourself up for that one. And engineering is a great entree into that. I have a former student who's now in the medical faculty at the University of Alberta doing research on minimally invasive heart surgery. So really, really amazing field and a big impact. Getting back to the space question, we have a big USST team here, so you can get involved in that right away. And a lot of the students that get involved in that team are doing engineering physics, but again, it's a very multidisciplinary activity. So that's a marvelous thing to do. Anything under the ground, sometimes mining engineering at the University of Alberta, it's geotechnical engineering. And then, yeah, that's right, geological engineering, sorry, the complexity of that name is sometimes makes us do loops. And then environmental engineering is another multidisciplinary activity that is involved with all of our programs. We'll see some environmental work. We also have an environmental engineering program that allows you to look at that in more detail and really dive into some of the holistic pieces around that. The one thing I haven't mentioned is computer engineering. And that one is quite interesting because you have to break it down into 3 parts. Software engineering is where you are building the software. We don't have an accredited program here. We have computer engineering, which has more to do with the hard parts, the boards, the electronics, the design of those pieces of equipment. And that's very different from computer science. So that's my very fast guide to all the disciplines. I want to emphasize that next year, you're going to have the opportunity to do 3 one-day intensive experiences where you get introduced to the 3 top disciplines of your choice during the period when you would have been doing exams at Christmas time. So you'll get a chance to do a really, really great experience around that. So that's my short answer. Hope that answers some of your questions and gets you started. Don't hesitate to reach out to us if you have more.
That's great. Suzanne, I'm going to get you just to leave your camera on for 2 seconds. And we also, Sean had just sent a little quick message in the chat, and they actually get to pick from 5 different majors during that immersive experience. So like you can totally have that time to sit and breathe and experience really what these different majors mean to you and how they connect, and what a great way to do that without being really rushed to make that decision. So we do have another question. Sorry.
No, I was just going to apologize to Sean because we went back and forth on that. I shouldn't have made that mistake. So he totally got me.
Hey, 5 is better than 3. We're only going up. And Suzanne, I have another question that has come up a few times here, and just a question about robotics, and if we offer any robotics courses, or of course the major. And I know the immediate answer is no. However, I think you might have a really great answer of how does that actually weave into the various disciplines that we do offer, as well as the extracurriculars like the USST team.
So I'm going to answer this in 3 ways. First, I'm going to say that your engineering degree is the beginning of your learning. So my oldest daughter actually works in a plant where they do a lot of robotics work, building airplane engines. She does not have a robotics degree. She has a mechanical engineering degree. Second, we are starting a robotics club that's going to be dedicated to robotics, and we're setting up a space to support that. So that will be in place, I think, within a year of us getting back into the building. We're going to be able to pull that off. We are looking at adding some robotics electives to the programming, and those will be combining mechanical engineering and electrical engineering into a multidisciplinary option. And so we're getting the pieces together to start to put that in place. But at the moment, we don't have a dedicated option. Okay.
I think that's a great answer. And you're seeing our students already dive in and take that and apply their knowledge that they're learning in their classes to make, I know even the USST team has their Mars rover, and the one that I believe went to Poland. I could be wrong on what model it was. But each wheel had each individual motor so they could act independently. They'd actually rescued a kitten in Drumheller using their Mars rover in their simulated mine rescue. So, I think our students are taking that and applying robotics right into their education and beyond. So we'll give you a break from talking, but I know there's going to be a few more questions we're going to circle back and ask you. But Blake Blackbeard actually has a really great question, and I think it's something that Sarah Bechter, maybe, or Noreen, you can answer. And he's saying that, or I should also, he or she has an interest in potentially pursuing the tech industry once they graduate, and is wondering what's the best way to get a computer science and a computer engineering degree. And I know we have that option for a few of our majors. So Sarah or Noreen, would you like to jump in and answer that question?
Sure, I'll jump in with this one, Carlene. So one of the great options that we have here within our college is the option for pursuing a dual degree between computer engineering as well as within our College of Engineering. So typically students would start that as an engineering student, you do your first year of engineering, and then we would work with you once you are placed into a major to consider that dual degree option. And so if this is of interest to you, we would strongly encourage you to meet with an advisor and we can do some of that program planning with you. What that would look like is extending out your degree. So your degree would look like a 5-year degree instead, and then you would complete with 2 degrees, right? And so it's a little bit different than other areas that how they define dual degree. So that's why we really would want you to meet with us. In terms of the difference between computer science versus computer engineering, this is a very common question that we get all the time. And so often we would encourage students to think if you are leaning more towards computer science, it typically would be more the software side of things, whereas computer engineering, and Noreen might want to jump in afterwards just because she has a little bit more seniority on me in this area, but within computer engineering, you're looking at both elements, right? And so what I've often heard our computer engineering professors explain is like, consider something like your cell phone, right? There's both the hardware side of things and the software side. So if that's of interest to you, where you integrate those components, then computer engineering as a discipline unto its own might be of interest. So that's just some information to help you kind of begin that discernment process.
Thank you, Sarah. That's a really good, once again, great explanation. Professor Mall, I'm going to get you to turn on your camera because we were talking a little bit about the robotics. I think even, working within the tech industry and combining computer science, computer engineering. There's a lot of questions, and you just threw something in our little internal chat that we have about the one group of engineering students is our CubeSat design team. So why don't you talk a little bit about what they're doing, because you're their faculty advisor, and I think they're really working on something that's a once-in-a-lifetime opportunity.
Yeah, thanks, Carlene. So what Carlene is referring to is that a subgroup of the USST, the U of S Space Design Team, is building a satellite, and it's called a CubeSat. And a CubeSat is like 2 Rubik's Cubes put together, and they are the only team in Canada where the students are doing all of the design work. They're designing it, they're building it, they're testing it, they're launching it, and they'll operate it in space. And it's due to be launched in the next year and a half. So when you come to Saskatoon, to the U of S, you'll be able to see that happen, the launching of our CubeSat called RadSat-SK. It has a radiation sensor on it. That's the scientific experiment on board. But the exciting news for you folks is that the Canadian Space Agency is likely to start another CubeSat program within the next year or so. And so if you're interested in space, you may be able to get involved at the tail end of our first CubeSat mission and at the start of a new one. And you'll be able to help determine what the payload will be and what the CubeSat is going to do. And so if you're interested in space, it'll be a really exciting opportunity. You could help build a satellite while you're an undergraduate student. And there are very few students in Canada that can say that.
Thanks, Sean. It's always great to kind of hear what students are doing. And I think that's one thing that's really interesting about lots of our design groups is the faculty relationship that our students and faculty have in that support and mentorship, but as well from the alumni side. I know Mike McGuire on the chat, and I've mentioned his rockstar abilities within EP, but he's one of our alumni that are there and actively engaging and supporting with our students. So I'm just going to go into the chat here and kind of see. Okay, sorry guys, just give me 2 seconds. Bruce, I'm going to get you to turn on your camera. I'm going to just give you one that we actually had in that came in before we had flipped on over to YouTube, that came in through the Eventbrite. And that is with the new re-engineered first year program, is this program accredited? And I guess just the accreditation question as the college as a whole.
Okay, well, that's a good question. So first of all, it's the entire program. So the first year forms part of all of our programs, and so each program is accredited. And so we've got 8 of those programs. They're all accredited, and they will continue to be accredited with the new first year program. And so we're going to have a visit from the accreditation board next year. And as part of that, they're going to look at the first year program and so that we can ensure that that we're meeting all of their requirements. And we're very confident that we are, because we designed the program in part with accreditation requirements in mind. So that won't be a problem.
Wonderful. Thank you, Bruce. Bruce, I'm going to get you just to leave your camera on, and I'm going to get Sean to flip on his. While we're waiting for Sean, thank you, Mike, for offering your email address and offering kind of an in-depth look into EP. And Mike's a great example. I know SpaceX has been in the news recently, and Mike has experience working there. So pretty cool that he's joining us today. Just a question about the re-engineered program. So we've talked a little bit about the no finals and the grading assessment in Caitlin's presentation, but do you guys just want to expand a little bit more about how the grading system works and the no finals?
Okay, so there's 2 aspects of it that are probably worth knowing about ahead of time that are important. The first is for any course, we consider there to be sort of 3 levels of material in the course. We call them type A, type B, and type C. Type A is very basic level stuff. I mean, you can think about it in a high school context as, can you multiply some numbers together before you do some more complicated trigonometry or something? So the type A stuff is going to be very sort of detailed, relatively simple operations, and you will have unlimited opportunities to prove that you can do that. It'll be an automated assessment system. And so you would essentially take those evaluations online when you wanted, and it would be, if you had troubles with it, you could try again and again until you get it right. That's type A. Type B is going to be sort of the meat and potatoes of a course. So in our statics course right now, we have, for example, 2-dimensional rigid body equilibrium. So there'd be sort of normal 2D rigid body equilibrium questions. You'll be taught how to solve them in class. You'll see examples, textbook references, that sort of thing. And you will need to demonstrate that you can do those basic types of questions fundamental to that course. We'll expect you to get at least 70% on that material to show that you have an adequate competency in that type of material. And then there's the type C material, which is the hard stuff, the tricky stuff. And those questions, there'll be no minimum requirements on the type C material, but those will be sort of questions that'll help spread your mark from 50% to 100% in comparison to your peers. So excelling in the type Bs and doing well in the type Cs will distinguish your marks from 50 to 100%. Now, all courses will be divided into modules. So for example, with the statics course, there are 3 modules. They're like 3 little mini courses, and you have to pass each module. You have to complete the type A material, get over 70% on the type B, and then you take your best shot at the type C materials. And those 3 modules each finish with a module test. So there's no big exam at the end of the course. There's just a module test at the end of each module. And that's why there's not going to be any final exams, because you're doing these module tests as you go. And in the new first year, in the re-engineered first year, the last sort of course you'll be taking in December will be that course where you get to sample 5 different engineering disciplines for a day each, and there won't be any testing associated with that. So basically, you'll be able to finish off the fall without a heavy set of exams at the end of December. Hope that makes some sense.
Okay. And if I could just add to that, I think a couple of the benefits, the things that you really have to pass, you'll get multiple chances to pass. And so it won't be just one scary final exam that you have to pass. You'll get opportunities to redo if you don't do well. And the second thing, that once you have mastered these type A and type B materials, then you can be really confident that you're in a good position to succeed when you go on to second year and beyond. So this will really ensure that you're well prepared for your upper year majors. And so we're really looking forward to that. And we really think that will improve performance, not only in first year, but all the way through the program.
Wonderful. Thank you so much, Sean and Bruce. I think you did a really great job of answering that. Bruce, I'm going to get you to leave on your camera. You can't get away from us quite yet. And maybe Sarah or Noreen, you guys can hop on and turn your camera. We're going to move this into a little bit of quick hitters is what we're going to call them for a Q&A or a rapid fire question with Dr. Sparling, Sarah, and Noreen. So I'm just going to list off some questions, and maybe if you can just give them in a quick and fast answer, that would be great. So our question here is, should I try to get into law school after 2 years of engineering or just continue with engineering? You just got to be quick and fast and jump into it.
I would say that you should finish engineering and then go into law school, because then you've got the credentials, and you never know where life's going to take you. And so that way you've got the best of both worlds. And so you will learn things in engineering that will help you in law school as well, and it will open up avenues for the type of practice that you might want to do.
And we've got lots of alumni too that have gone into law after their engineering degree and are extremely grateful to have that foundation of engineering, once again, kind of tying back into what Professor Moss said of just having that good base knowledge of engineering and that problem solving skill sets. Okay, so we're fast tracking, I'm rambling, so we're going to jump into the next one. Speaking of fast tracking, is fast tracking an option in engineering?
At the moment, maybe I will say no. You need at least 4 years to complete the engineering degree. It's because of not just the load, but the schedule of classes and also prerequisite requirements.
Yes, so engineering tends to be, you build on the knowledge that you get year by year, term by term. And so you really do need to go through the whole thing and in the order that we have sort of laid it out.
And Dr. Sparling makes a really important point, right? In other programs, whether it's at our university or elsewhere, if you're looking at curriculums, sometimes in the College of Arts and Science or other programs, they have what's called a spiral curriculum, right? Ours is a lockstep curriculum. So each step, it's like a step on a ladder, it's building, right? And that's why you need that sequential knowledge and that knowledge base to build on, which is different from other colleges or programs.
So here's a little bit, we're going to flip over into the EP side of things, or I should explain that EP stands for engineering physics, and that's just our acronym that we use. So which, if any, disciplines of engineering have the most or anything revolving around space and physics, and what are some of the common jobs in that area?
Well, I think that usually...
I think Sean wants to jump in on this. So Noreen and Sarah, I'll get you guys, just so we can keep our bandwidth nice and healthy, I'll get you guys to quickly pop your video off and we'll pop it over to Sean.
Any discipline can get involved in the space industry. I keep a pretty close tab on it. But at the U of S, EP is probably your most direct way in. Certainly we have a lot of electrical engineering students and computer engineering students in CubeSat and working on the rover as well. Mechanicals, lots of them too. Civils, geos, enviros, chemicals, they can get involved. There are roles to be had, but they are more specialized roles. And, you know, China's just launching in a couple of days, China's launching another mission to the moon to get samples and bring them back. SpaceX just started its regular operation to the space station. I mean, you are so lucky if you're interested in space, the opportunities will be endless, and not just for the EPs and the electricals and the mechanicals. Civils are going to be in demand on the moon for building moon bases, and that is happening. That is coming, led by the commercial space industry, actually. Geological too, of course. Environmental engineers will be needed because the standards for environmental controls will be harsher than anywhere else on Earth. And chemical engineers, they're the ones who help get you there. So there's lots of opportunities if you're interested in space. However you'd like to go, you should pick the discipline that you're passionate about and then figure out how that discipline relates to the activities that you're interested in.
That's a great answer, Sean. I think lots of students might naturally or quickly think that EP is the answer, but I think you answered that perfectly, that, pick your major by your passion and just follow that. So on to our next of our little bit of rapid fire questions. It actually looks like we potentially could have covered all of our quick and rapid fire questions. I do see that Dean Suzanne Cresta is back in our audience. So Suzanne, I'm gonna get you to throw on your camera for a quick second. And
disciplinary, and I have a brother who got involved with this. He got started late in his undergraduate degree as an electrical engineer. Mechanical engineers have a terrific background for this. It really is a very multidisciplinary activity. So I'd encourage you to continue to watch for it. Pick up something like anatomy as you go through. And the opportunities at the University of Saskatchewan include Sask Invents, which does design for biomedical applications as an undergraduate club, doing research in the summer or as a co-op term with one of our active groups, and then moving into that as a graduate student if you want to get a more in-depth experience. And so that would be my take on it. I want to pass it over to Dr. Sparling to see if there are things he'd like to add.
Actually, Suzanne, I think you covered that very well. I think we are offering more courses at the undergraduate level that are relevant to that and can help build towards that. And as you said, there's lots of opportunity for undergraduate students to get involved in the research side of that during the summer. And so if you're interested in that, then certainly we can put you in touch with the right people to talk to, and so they can tell you all the exciting things that are going on. And it really is, it's an incredibly exciting field right at the moment.
And another thing that might be worth noting at this point, I don't think we've talked about it so far, is that we do have a program here at the University of Saskatchewan and the College of Engineering for engineering entrepreneurship. And the dean had mentioned the Sask Invent group, and they are very entrepreneurial. And so we have groups and students in our college who are keen on starting their own businesses and being tech entrepreneurs. And we have people here who can help you with that. So if you're interested in that side of engineering, we can help you, and we'll certainly be there to support you.
That's great, Sean. And I think just on the entrepreneurial front, we have alumni that have been, if anyone's a fan of Netflix's and CBC's show, The Dragon's Den, we've had people on both sides of both the dragons. So we've had Brett Wilson, who's one of our alumni, and quite a few alumni that have also pitched and gotten Dragons money that are engineers. So Annika, I'm going to turn on your camera because we have a really great question that came in from Michael Z, asking about how much time do you study per week? And I know that probably flexes and ebbs and flows just like everything else in life. And then just balancing, looking at design clubs and the time that's committed for that, as well as just flexing your general social time. And I know you're probably actually one of the best students in the college to answer that question.
Thanks, Carleen. So for first year students, I can't necessarily speak for all the teams, but they are fairly similar. And for HFR specifically, we have shop days once a week and one night of meetings. So for a first year student, it's maybe 8 hours a week type thing. As you take on leadership roles on the team, there does tend to be a fair bit more time involved. But of course, you don't have to take on a leadership role by any means. I will say though that the more time you put into one of the design teams, the more you'll get out of it, absolutely. I would also very much recommend, if you are interested in one of the design teams, get involved right off the hop. If you decide it's not for you, then that's totally fine. You can always quit the team or change over to a different team. But I definitely say that if you get involved when you start university, then you're better able to make a schedule that allows you to balance your studies and your social life and a design team or one of the other student groups, rather than trying to fit in time for the design team later on.
And I think the one really great thing about the design teams, and in terms of social, it's kind of a 2-for-1 package, right? Is that you get to socialize, make a lot of friends, but then you're also working on the design team. I know when we were back in the building, you were often in the building late, hanging out with the team, but also working on the car. So it's kind of nice is that you build these lifelong friendships through the teams, but there are also people that, one, you're hanging out and working on the car, but then you never know, there'll be helping you with classwork and everything like that. So I think, there's a lot of perks to being involved and just building that friendship. And I think with the new re-engineered program of having the shared common time slots will be really awesome for lots of first years to get involved with different design groups. So thank you, Annika, so much for answering that. You can turn your camera off. I'm going to just maybe quickly get Sarah or Noreen to turn on your cameras and maybe just circle back and just speak to the one math question that we had regarding transfer credit. So I don't know if any one of you guys would like to tackle that. Or if you think that we could just throw, they could always email us too at the ENGR or the engineer.recruit@usask.ca email too.
Sure, I can take this one, Carlene. I think Noreen has her hands full with something else at the moment. So as all of our students know, we're in the process with the new first year curriculum redesign of mapping the curricular outcomes from the new courses onto what would be the transfer credits, right? So whether that's AP Math credits or Math 110 or other external first year calculus courses that students might be coming in with. And so our college, we're just under that review process at the moment. And so at this point in time, those are still just kind of being finalized. So we do ask students, please contact us at the Engineering Student Center at esc@usask.ca. And as soon as we do have final decisions, we will start releasing that and communicating that, but we're just finalizing some of these details as it pertains to the curricular outcomes in the new program.
Wonderful. Thank you so much, Sarah. Just keeping an eye on our chat, and it looks like things have quieted down a little bit. But I also just want to reassure to everyone tuning in, or even if you're watching this stream after the live event, is that you can always get a hold of us at engr.recruit@usask.ca. And what we'll do maybe is that we'll just throw that in the chat. But if you have any questions, or maybe you're a little bit shy to throw it in the chat, send us an email. We'd be more than happy to talk with you and go through the whole application process with you. So I think with that, it doesn't look like any more questions are coming into the chat. I'm going to get Suzanne and Bruce, if you guys don't mind, just turning on your camera and maybe just give us a few parting remarks on behalf of the College of Engineering at USask. And this is another touch point that we have with our engineers, and hopefully we'll officially get to welcome them into the college next year. But I'll leave the closing remarks off to the two of you.
Bruce, I'm going to let you go first.
Okay, I just like to say that I think that the College of Engineering, as you may have got a sense of this from the question and answer period and from all the videos you've seen It really is a very close community. We try very hard to get to know our students and to have the students sort of interact with each other. So I think we're very great size of college, and I'm sure you'll enjoy the experience here for a number of reasons. I think we have great programs and great people. So I'll pass that to Suzanne.
Thanks, Bruce. This is the 4th engineering school in Canada that I've worked at. And I think that the University of Saskatchewan is a really, really special place. The first year program is way ahead of what other colleges in the country are doing. And it's really, really well aligned with what you will see in your careers. So I think we're setting you up to really be a step ahead of the rest. The commitment to interaction with students here is far and away the best I've seen anywhere. And we really are thrilled to have had you join us this evening to get a taste of what might lie ahead for you. I do want to thank all of our staff who stayed late and who worked really, really hard to put this together. We're all living in a new reality and reinventing the world around us as we go. And I hope that you've really enjoyed the program, because I know that a lot went into it and you'll be able to play it back later if there are pieces you want to go back to. This will be staying up on our channels. So thanks everybody for signing in, and a big shout out to our team who really put together a great event.
Thank you so much for everyone joining us today, not only to answer in our live Q&A, but a huge, huge thank you to all the students for tuning in across the whole entire globe. It's pretty exciting that we have the chance to say that. And I really hope we get to welcome you as a future USask Engineering student next year. Just once again, if you have any questions or would just like to sit down and talk through the program options, shoot us an email. You can reach us at engr.recruit@usask.ca, and stay tuned to your emails because we'll be sending a few other exciting opportunities. And you might want to make sure that you check on those as well, because guess what? You might win one of those Echo Dots or some of the gift cards or our custom engineering socks. So with that, I will formally sign off on the virtual edition of 2020 What is Engineering, broadcasted live from the College of Engineering at the University of Saskatchewan.